Hello everyone, welcome to the Inferential Statistics tutorial by Intellipaat. All of us know how important mathematics and statistics are if you wish to become a data scientist. I would go beyond that point and say that it doesn't even matter if you have technical programming background or an engineering degree behind your back. You still can become a data scientist if you have a love for numbers and mathematics. Now don't get me wrong here. I'm not saying that programming is not important. Rather, what I'm saying is programming can be learned over time, and it is not the case that substantial programming is expected out of you. You just need enough knowledge and skills to make machine learning models work. Understanding math and statistics is crucial because every part of data science is based on them. If you don't understand the basics, you'll end up just memorizing instead of really understanding. This means you won't be able to solve new problems effectively. Today, we are going to teach you something important in math called inferential statistics. Our experts from around the world have put together this detailed tutorial for free. We have made sure it covers everything you need to know. So ensure that you stay till the end. Also, before we begin with this session, I would like to express gratitude to all Intellipaat subscribers for helping us become the biggest edtech organization on the YouTube platform. Thanks to all of you guys, we are almost here to reach 10 million subscriber count. We promise to keep on producing quality educational content, so keep supporting us. If you are new here, don't forget to hit that subscribe button and the bell icon to receive more technical updates from our end. Having said that, let me quickly take you through the agenda that we have for this session. We will begin with understanding what exactly data science is along with its types. Next up, we'll discuss basic statistics terms such as mean, median, variation, standard deviation, etc. Later, we will cover multiple sampling techniques like random, systematic, and stratified sampling alongside terms like z-score, normal distribution. Moving further, we'll understand how you can configure this inferential stats using Python programming language. We'll also look into important statistical concepts like confidence intervals, hypothesis testing, one sample t-tests, and ANOVA. I hope I have made myself clear with the agenda, so let's directly dive into the session.
Ideally, if someone will ask, what is data, types of data, just say categorical and numerical, simple. Something that you can categorize or something that you can calculate, or you have a number. Okay, so it is like qualitative, quantitative, something that you can quantify. A numeric value, yeah, Iqbal, you are right. A numeric value can be quantified, and categorical value is quality wise, good, bad. So these both the things would come under one under categorical, one under numerical. Okay, clear? Okay, now under categorical, so categorical means giving it in, putting it into a category. Okay, so that is, you can say quantify, quality types, qualitative and categorical will be on similar lines. And quantitative means you can quantify. That means you can get a number, 10 shoes, 20 shoes, 100 shoes. That would give you an answer in numerical terms. You understood? So quantitative would be and would come under numerical, and qualitative would come under categorical. Okay. Process data means what? Process data or structured data would be on similar lines. Yeah, correct. Quantitative is related to quantity. Qualitative is related to quality. Quality means giving a rating. Category. Quantitative means it's quantity. Quantity means it's a number. Okay. Processed data. Yeah, processed data or structured data is very similar. The data would be like in rows and columns. It would be in rows and columns. Okay. And unstructured data would be, like, is my voice breaking? Akshata is saying my voice is breaking. Is my voice breaking? No. No. Okay. Was before. Okay. You want me to change my, but the network at my end is fine. Okay. So basically, it's quite high. So basically, we have two unstructured data. Can you give an example of unstructured data? Can you give me an example of unstructured data? Okay. Pre SQL also is there. Pre SQL, but data, not database which is going to store. Post, there is one post GRE also now. Yes, email content. Post GRE SQL, something like that is there, no? What is it? That latest. Yes, image and video, text. Okay, sentiments or Facebook comments. Sentiments and Facebook comments. So that is unstructured data. So if someone will ask you structured data and structured data available in rows and columns. Okay, and unstructured data available mainly in English. Okay, English or language. Okay, there is one semi-structured also. What is semi-structured? There is one semi-structured data also, which you can read using pandas. What is this partially sorted means? Any language we use which uses semi-structured. Have you seen a program, a code of HTML? HTML language. So it writes like this. Okay, HTML. It will write in a code. Hello world. Okay, and then say I'll copy this, and then it will /HTML. This is a very basic HTML page. Okay, if I open it in browser, it will work. So this data, there is information, but in a semi-structured fashion. So I can put this in a paragraph also. I can put this in a paragraph, but they are all in what we call these tags. These are called as HTML tags. HTML tag, or I can put it into a header. Further, I can put here H. And I'm closing the tag also, because everything that I write after hello world will become heading H1. So who has done coding this correct? It's been a long time. Who was it? Unstructured data is not meaningful. Nitin? Okay. So some things you can also like put, I mean, you can add, okay. So you could have already, you can just suggest that just write this statement, because I'm thinking also, I'm writing also, no. So maybe sometimes I might not be able to put the thoughts in the right way. So if you feel, just tell me that change this statement, I'll change it. Okay. Okay. So now what happened? So this is, yes, what you said was JSON and XML also. Correct. You're right. XML. Many people don't know XML. And JSON also. Okay. So you're right that this happens. These are the things that, so this is different type. Now in this categorical data, I have nominal. Why discrete? Why nominal? Why ordinal? Ordinal is not city, state, country. Saket, ordinal. Can you say that country state, city, or city will come before state, state before country. It's not like that. They have their own importance, right? If you have states, then can you put them in a certain order that Maharashtra will come before Chhattisgarh? Yes, just like how male and female, who will come before, we cannot decide, but there are two values, male, female. Can you decide which will come first? Is female going to come first or male going to come first? Like that, they are nominal. Okay, the order doesn't matter. So when someone will ask you nominal, no, when someone will ask you nominal, no, just say does not maintain any order. Example is male or female. In the data, when you have data, that time male or female, who will come first, that is not important, no. That person is a male or a female, that is important, correct? No, agree? See, think from that perspective. You are having rows and columns. In machine learning, you are going to have rows and columns. There is one column which is about order. So I have how many? I have so many people. I have 77 people in my class, and I have male and female. Okay, they must be using Flipkart. I get data of Flipkart. Okay, I got data of Flipkart, and then in the data, I see a column called as gender. In that column, I can see male or female. So who will come first? Male will come first or female will come first? Any can come first. Any, but they are categorical, no? They are categorical, no? That means I'm able to categorize that person into a male or a female. If I draw a graph, of male and female, I'll get male, I'll get female. I'm able to categorize, but I cannot say who is first and who is second. Agree? So think from data perspective. Think from data perspective. Don't think on literal terms now. You want to become a data scientist, no? So you have to think everything from data perspective. Okay. Now, if nominal is this, then what is ordinal? So maintains and order means excellent, good, average, poor. So will good come before excellent? Will good come before excellent? No. So it is maintaining an order. Agree? Agree that it is maintaining an order? Okay. So this is nominal and ordinal. Correct. Saket is correct. High school, bachelor degree, master's degree, PhD. Very correct. Okay, this is a very good example. So let's do it the other way around. PhD, then MTech. I think MTech, Masters, MTech, say MTech, then BTech, then 12th or diploma, and then 10th. Yes, you can also say that country, state, city, but they are important in their own way. That also can be ordinal. Economic status, very good example. High income, no, high class, middle class, lower class. There are classes in this also. Any will do. It is ordinal, no? Anything will do. Ascending or descending. Okay, understood so far? Story is okay, because I have to build a story from here to inferential. No, don't need PhD, my friend. You don't need to be a PhD to be a data scientist. You should only be able to understand data. Okay, don't need to do a PhD. That's what I'm saying. Try to relate to data. That's why I said no, male, female. Look at it from data perspective, not just male and female. What data you are going to get in that when you see a column, there is no way you can say male will come before and female will come later. Okay, you understood my point? You have to look at it from the data perspective now. Think from data perspective. That's why I'm starting from data, no? So this is, you have covered this in your descriptive statistics this way. You have covered this way. Number of orders on Amazon. Shoe size. Cannot be infinite. So discrete, what is, when you say someone will say discrete, it cannot be infinite. Example, shoe size. Shoe size is what? It can start from 6 or 38, 39 to 42, 38 or 12. We start, what is the child size? Shoe size, minimum child size? Minimum child size 5. 5 to 44 I have seen. 10 size, 11 size, right? 5 to 42, 44. UK, this is US size. US shoe size 5, it starts from 3.5 to 12.5. Okay. Discrete data, if you look at this example, This is US men size 3.5 US to 12.5, or in UK size 3 to 12. This one I was in India, we use this 35 to 46.5. Okay, it will not go beyond that. If someone's size will go beyond this, no, he has to manually make a shoe for himself. Can you see? So I was looking at this 35 to 46.5. 35 to 46.5. Okay, 35 to 46.5. Let's assume this is what. So there is a specific size. Okay, discrete number. Okay, there is a discrete number for this set of values. Okay, so that means what? If you're designing a front end screen to accept a certain shoe parameter, shoes, you're designing a screen on which you are accepting shoe parameters, shoes, and you have put one of the column names, one of the input text box you have put as shoe size. So you will put a drop down, no? Ki Baba, my shoe size cannot go beyond this. You understood my point? You understood? So we'll say that is a discrete value, no? Say you have a screen. On the screen, you are taking values of a shoe.
Just a quick info, guys. Intellipaat offers a data science course which will help you master Python, SQL, machine learning, AI, and Power BI. Get a data science certification from IIT Empowertak and Innovation Hub of IIT Madras. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height. So visit the course page link given in the description and take the first step towards the career growth with the data science course.
For a shoe, say Bata. Name of the brand, who is the seller, who is the distributor, shoe price, shoe size. This shoe size is going to be of a drop down 5, whatever sizes Bata use, 6, 6.5, 7. This will drop down will go up till 12, 12.5, whatever till Bata is wishing to sell. This kind of a field is called as discrete data. Clear? We are clear? On the screen, if you see a drop down where only selected values are there, it is discrete, no? Iqbal, did you get my point? On the screen, if you have a field drop down, when you are going to shopping in Myntra, and you are going to select a size, drop down size, say on a screen you get a drop down size, 5, 6, which size you want. That is discrete value, no? You got my point? What I'm trying to say now? Everyone understood what I'm trying to say? Yes, version. Even certain places have version that, okay, what about Android version? Android version is also there. So that's what I said. It cannot be infinite. Anything that is countable is discrete. Yes. Correct. You're right. So what is continuous then? What is continuous then? Profit value. Everyone understands profit, no? Profit and say profit. A profit can be, say I bought a, okay, I bought a shoe. I bought a shoe. I'm a, yes, profit. So one simple example is I am a shopkeeper, I'm a trader. So I buy shoes at $100. I sell them at $111. Okay. So what is my profit? So this is a continuous value. This is a continuous value, no? See this, it can go on a number line. This is a continuous value. On a number line, I can tomorrow have 0.314 also. I can have 0.315 also. It is a continuous value, no? On a number line, any value on a number line, any value on a number line is what we call as continuous. You understood? Any value on a number line. So continuous can go. What is the quality of continuous? Can range from, if continuous, the value can fall between infinity and positive infinity. Okay, so now data type is understood, right? So if I make a table, can you tell me? Machine learning is like going to an astrologer and telling me what is going to happen tomorrow. Machine learning helps you to predict what is going to happen tomorrow depending on data. So astrologer, you go to astrologer and you show your hand, no? Baba, what is going to happen tomorrow? What is going to be my future? Machine learning is going to predict the future depending on the data. Say you have been working on a company. Yeah, correct. So you are working, you have a company You have a company which has been running for 75 years after post independence, and now you want to analyze that data and check which product can do better, which product can do good business. That is machine learning, but it's the future. Yes, deadly combination, CA plus machine learning. Very nice. It is very new. It is very new. And if a person goes into it is applied in medical also. So there are different domains in machine learning. You have finance domain. So I had worked with a CA in ERP. Okay, listen to the story. I had worked with a CA who was I was in ERP, manufacturing ERP. Every ERP, be it finance, be it banking ERP, or be it manufacturing ERP, it hits transactions, it hits finance. Finally, every business works on profit and loss. You need CA. In IT sector also, there are so many CAs. I have a couple of CA, my friends who are in France. From here, they have gone. I used to work with them. And it is a deadly combination, IT plus CA. It's a wonderful combination, very rare, and they have very big potential. It's okay if you know maths, machine learning will go very easy. You know statistics, you know probability. If you know statistics, if you know probability, machine learning is very easy for you. If you know what is a line, how a line, what is the equation of line, you know linear regression. If you know what is the equation of a line, you know what is linear regression. It's okay. You don't need to be technical. You don't need so much technical in machine learning. You don't need to be high class technical. You can start your career in data science, but you should have the knack to understand data first of all, because you want to become a data scientist. So there it is made up of two words, Gulam. Data scientist. So who is a scientist? Who understands data. That is the reason why I have started with data. Gulam. Ki what are the types of data, Baba? What are the types of data? And then you are going to analyze pattern. You understand my point, Gulam? Understand? So you are going to find patterns in the data. That's what I said, no? That a person, a CEO company, a CEO of a company, and he has decided to understand what has happened in the last 50 years. My grandfather started the company. After 50 years, what is the situation of my company? I want to know. This will hit into your any domain. Finally, it is money, no? Finally, you have to calculate money. You need a finance guy. Everywhere it is needed. It is one of the hot things. And what he is doing, no? CA with ML, he will be picked up left, right, center, even maths. But because you are maths, you have a background of maths, you are already analytical. And because you are analytical, you should be able to understand machine learning. It is not difficult. If you ask me, it's not difficult. Machine learning is not difficult. Deep learning, slightly higher level, to be honest, deep learning. But machine learning, I don't think it is difficult. You should sail through. Even you don't need so much of statistics also in machine learning. Okay, so can we come back to track? Okay, so you guys up till now stories you have understood whatever we have done up till now. Data part 1. Okay, so part 1. So good. I mean, this guy you said CA, no, he was a very good friend of mine. He was with me in UK, and he's in France now, but very intelligent guy. I used to sit with him. I'm technical, he's finance, and I used to sit with him. He was CA. He was so good at solving financing. I learned so much from him. Data science and data analyst both are same. Data analyst will only help you analyze the data. Data scientist can build a model and help you give predictions. Data scientist will decide, depending on the data, he will decide what kind of model to use. There are 12 models in machine learning, and he will then decide which model to use, and it will help you do prediction. What the business wants, Baba, depending on our past experience, what should we do in the future? Okay, like how we are walking on a road. We are walking on a road, we fell, we got up, we fell, we got up. Now we want to check, go back and see, I don't want to fall again. What to do? You can say that. Sunny, you can say that. Data scientist is a superset of data analyst. Yes, you can say that. Stock market prediction comes through deep learning. Deep learning has a concept of LSTM, long short term memory. Stock markets use LSTM, RNN and LSTM, recurrent neural network and LSTM. It is deep learning, not you. Generally, machine learning doesn't work that well. Deep learning. Okay, so can we come back to that? There was a huge demand of big data, but they realized that, and having so much data is one thing. We need someone to analyze that data also. No, big data means lot of data. Having data is one thing. So much data, we need to handle so much data, but who's going to analyze this big data? That is the reason why the demand of data scientist has gone up. Okay, even in recession, there is demand for data analyst and data scientist. Okay, so let's move further ahead. Let's move further ahead. And there was, you must, in your descriptive statistics, your friend, I don't know. I don't know what is included. I just know I have to take your inferential statistics. That's it. I don't know what is your course and what course are you guys, which course are you guys doing? What, everyone is from the same course? Okay, some IIT MIT batch goes on. It is like that? IIT MIT batch or like that? Yes, you want to know the names of the models? Okay, machine learning models. Someone asked me machine learning models. Regression. Okay, I won't go deep into it. Huh? I'll just name them. So that is XGBoost and all. Now they are boosting the accuracy. Okay, how many? 1, 2, 3, 4, 5, 8, 9, 10, 11. Okay, and have I left something? So these are related, these are mainly called as supervised learning. Yes, you can say that. One. So this is actually supervised learning. Supervised learning techniques. Okay. And this is unsupervised learning technique. Unsupervised. And this is also unsupervised, you can say. And these two are actually, I should take it like this. In this, no, there are two. In dimensionality reduction, no, there are two. PCA, LDA. Okay, I have two in dimensionality reduction, PCA, LDA. Okay, so it works like this. Then and these are actually data mining. These two are data mining. Mine the data to get the rules and mining. This recommended system is used in OTT. This is data mining. Okay, so generally the journey is Python programming, which leads to statistics, inferential and descriptive. You don't need to go too deep. Okay, then from here you do machine learning, and then from here you do deep learning, and then from there, if you want, you do some BI tool. It can be Tableau or Power BI, whichever. Yeah, there is one more, or there is one more in the middle. Natural language processing. So this completes the loop. This actually completes the loop. Okay, so this makes you a data scientist. Why it makes you a data scientist? That also I'll tell you. Okay. This ML, machine learning, takes care of structured data. Analyze or predict from structured data. Is this a time waste, or should I get back to statistics, or you want this information? You want me to go back to statistics? Okay. So ML takes care of okay, listen to me. ML takes care of structured data. ML helps in predicting. ML helps in performing predictions on structured data. Okay. Okay. Now DL is deep learning, helps in performing predictions on images, voice. Okay. Images, voice, speech. Okay, speech. NLP helps in analyzing the unstructured data, or you can say unstructured data means comments, feedback, which is on neural network is deep learning. Okay, so I'll write here. Okay, ML is machine learning. DL is deep learning neural network. Deep learning is part of deep learning neural network. Okay. Time series. Absolutely right. Time series. I There is one more, but that is a different topic. There is one more that is not an algorithm, but there is one more offshoot from this, that is reinforcement learning, but that is a different altogether. Okay. So generally they do this. NLP, yes. Natural language processing. Okay. All three. This information is enough for you to get an idea why you are doing this course. So you have tried in this course, all kind of data is analyzed. You are becoming generative AI. I have not reached generative AI. LLM and all, I don't know. I have not yet I've not worked on generative AI. That is my next step. Okay, prompt engineering, generative AI, that is something after this I want to do, so I can't comment on it. So generative AI is what, all this deep learning, no, is data hungry. The more you give data, the more it learns. Okay. So generative AI, or you can say large language models, they require a lot of data and they require a lot of processing time. That's why they need a lot of GPU. Yes, yes. It is like this. AI, subset of AI is ML, subset of ML is DL. Clear? So did you not have a orientation or anything? Why this course and what you are going to do and what are the things that why? So this flow, you don't know this flow. This flow. Now you know. Now you understood why you're doing this. Now you understood, no, why the flow. What is important is why this flow. Why am I doing all this? So in this ML, you are able to understand, you are able to analyze structured data. In DL, voice, speech. In NLP, unstructured data, where you get English. From English, you want to generate some information from English words that people have written in language, like paragraph. Comments can be written in paragraph. The whole paragraph, you are not, yeah, are you going to say, are you going to, you need something to analyze that whole comment, 8 lines, 4 lines, and decide it's a positive comment or a negative comment. Sentiment analysis, it is called. It is called sentiment analysis. So this everything is done by NLP. Okay. Yes, yes, Iqbal. Okay, so now let's come back. So we then try to understand what is central tendency. What is central tendency used for? So before I come to central tendency, I think your instructor in the last class, he must have taught you mean, mode, median, mean, median, mode, then variation and standard deviation. Okay. Okay. Now tell me mean, median, mode, variation, standard deviation. Okay. Can you tell me what is mean, median, mode, variation, standard deviation? Mean is the average value. Mean is average. Okay. So if I come to mean, okay, I took height of 10 students. I took height of 10 students. Okay. Student number say, and the height. I'm going to ask you one question in some time. I'm going to ask you a question. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, and insert. Okay. 9 and 10. Okay. So I'm taking height. Okay. Now listen to the example and tell me what I'm doing. Okay. Look at the example. Okay. Look at the example. 155, 158, 156, 166, 162, 172, 175, 170, 171, 165, 159, 172, 170. Okay, these are the height of my 10 students. Can you tell me what is going to be the mean? Mean is what? Can I calculate the mean? Mean is average. Average. Average, no? Average. So it is sum divided by total number of points. It is sum everyone with me, divide by total number of points. How many total number of points is 10? This is correct. Correct. Mean is correct. Okay. What is median? What is median? Yeah, but there is a rule for median, no? To calculate the median, yes, sort the data in. First, sort the data in step 1. Sort the data in ascending order. Okay, step 1. Sort data in ascending order. Okay, so Baba, this is my data. Okay, smallest to largest sorted. Correct. Okay, now tell me how you are going to calculate the median. How will the median be calculated? One, two, three, four, 5. 5 and 6, right? You have to take 5 and 6, no? You have to take 5 and 6 and divide by 2 because it is even number. Even number is the middle two, add them, divide by 2. So this is equal to, who is the middle number? Middle number are the 1, 2, 3, 4, 5 plus the 6th one, divide by 2. So this is my median. Correct, everyone? So if it is odd number, then what? If it was odd number, then if I had only 9 values, these 9 values, then what? Then who would have been my median? Middle value. 1, 2, 3, 4, 1, 2, 3, 4. So 1, 2, 3, 4, middle one, 165. Directly the middle value. Correct? So far, so good, everyone. How many of you are there? 82 people. All understood what is? Okay. So now what is mode? What is mode? Most repeated value. So do we have a mode here? We don't have a mode here. Okay. If we want, we can create a mode. Okay. Instead of 175, let me make it 171. Okay. So this becomes 140, and instead of 175, I made it 170.
Just a quick info, guys. Intellipaat offers a data science course which will help you master Python, SQL, machine learning, AI, and Power BI. Get a data science certification from IIT Empowertak and Innovation Hub of IIT Madras. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height. So visit the course page link given in the description and take the first step towards the career growth with the data science course.
Yeah, 175, I made 171. Okay. So 171, 175 became 171. So median will also change. No, it doesn't change. Median will not change. Sorting will change. So median will not change. Mean will change, and most repeated value, which is mode, is 171. This is clear? Everyone is clear with this? Yes? Okay. So Baba, you took height and you took, okay. Now what is variation? What is variation? Now comes the main thing. What is variance? Variation or variance? So variance is how far is each point from the mean, correct? Yes, how far is each point from the mean? Okay. So let's assume I have one child here. One child, second child, third child, fourth child, fifth child, sixth child. Okay. And I am saying this is my mean value. This is mean. This is mean. So what I want to know is how far is this guy from the mean? Okay. How far I am from the mean, because I'm not looking at just one point. I'm looking at multiple points, right? Agree? Agree? Yes or no? I'm building a story, okay? Towards inferential statistics, I'm building a story. Okay. What is the unit of height? What is the unit of height? If I had to tell you, this is what 170 watt. We have taken centimeter. Okay, centimeter. Okay, unit is centimeter. Okay, clear? Okay, now I will keep this. I will keep this as is. Okay, I will keep this image as is. Can I save it? So this is important. Why it is important, I'll tell you. Okay. So now I want to know, when we have something called as variance, why are we having standard deviation? Now, what I'm going to tell you is very important. Okay. Story is that, Baba, I have two formulas. One is variance, one is standard deviation. And this is my situation where I have taken height of 10 students. Now I'll calculate variance first. Okay. Formula of variance is the value minus the mean. X dash is the mean. Okay. So let's take this. Let's take the mean. This is very important. Please listen and understand what I'm saying. Okay. It's very, very, very important. This is our scenario. And this is my variance. Okay. For variance, I'm saying this is the mean. So I got my mean. So I have my X, I have my mean. What is the formula? It says X minus X dash first. So X minus X dot bar. So this is equal to, everyone is looking at the screen, no? This is important. That's why I'm telling you. This is equal to this minus this value. Okay. So I'll make this standard value. When I pull it down, no, this value will not change. M82 will not change if I drag it down. So I dragged it. This is my X minus X bar. What he's saying after that? Square them for all the values. Square. This is equal to, so this is equal to this square. Okay. I got a square value. Then what he's saying, sum it, total it. Sum. So this is equal to sum of these values. And then to calculate the variance, we divide by 10. I got variance 38.44. Is the variance from the mean 38.44? Is the variation from the mean 38.44 when you look at the diagram or look at the values? This is 164. Are the values 138.44 away? Where is the problem? Where is the problem? So X minus X bar, X. So what is the unit of X height? Centimeter. Okay. What is the unit of mean? Mean is average of this. It is also centimeter. It is also centimeter. Mean is also centimeter. Yes or no? Yes. Difference. So this difference is also in centimeter. I squared the centimeter. I squared the difference. So this became centimeter square. So practically, I'm getting a value which is centimeter square. So this variance, what is the unit of this? Centimeter square. But that is not what we are looking for. That is not what we are looking for. We are looking for how far this guy is from the mean. How far this guy is from the mean. That is the reason why I need standard deviation to bring this back practically to normal. So to bring this guy back to its original unit. So standard deviation is equal to, this is equal to square root of this value. This is in centimeter. So I'm saying at an average, this guy is 6 centimeter from my mean. This guy is 6 centimeter from my mean. Variance is not telling me that. Standard deviation is telling me that. Variance is not telling me the different, how far I am from the mean. When you will plot these values, so standard deviation is coming from variance only. When you plot these values, you will be plotting them like this. You will get a plot like this. It is just showing. So standard deviation is showing the variance from, it is showing how far the, I mean, how would you put it? So it is actually standard deviation is telling me this. At an average, how far am I? At an average, how far I am? So I have three streams. All three streams start after 12, right? BSc also we do after 12th grade, BE also and BC also, correct? Is it true? Diploma we can do from 10th, but generally, yes, okay. So let's assume the student count. So 3 courses. Student count is student count is 500 numbers, 500, 500. Total 1500. Now you have got a project. What you are going to do? You are going to take height of 1500 people. You want to calculate average height. You know how to calculate average height. You know what is central tendency. So you are going to take what? 1500 people you are going to catch and you are going to take height. So what is your population here? If I use the word population, who is your population? The students. 1500 students is your population. Okay. Generally, from this, at least you will pick sample. At least you will take 150 numbers. Sample at least should be 150. This is just example. Okay, because your number is 1500. No, if it was 1.5 lakhs, then what will do? So here it is 150 is 10%, but it is 1.5 lakhs, you will go to 1%. Okay. So sample. So let's assume you decide. It is your call. You have 1500 people. You can have 15,000 also. You want me to increase the number? Let's keep it 1500. Okay. So you decide that the sample size, total samples, will be 150. Now, how will you pick the sample? Nothing like that. No minimum ratio and all. It's not like that. If your size is in lakhs, you can take 1%. Thousands, you can take 10%. It is up to you. It is a call how logistic wise it works for you. Can you go to, say, if I tell you, tell me the average height of people in India or in a state or in a particular, what do you say, zonal area, then how you'll do? Imagine the number of people living in zonal area. Okay, which zone? Pune comes in which zone? Okay, forget it. Okay, so how will you decide? How will you pick these 150 people? What are the techniques that can be used to pick these 150 people? So there are three techniques. Okay, so now we are going into inferential. This is your inferential part. Okay, so from this example, we are picking a bigger example. So techniques are random sampling, systematic sampling, and stratified sampling. Okay, these are the three techniques. So what is random sampling? I'll tell you each of them. Okay, what do you think is random sampling? What will happen in random sampling? Say, think practically. You are doing this project, you have to, and you decide to do random sampling, then what will happen? Okay, first point, random sampling, very important point. Very important point. Okay, each student from the population has an equal possibility of getting selected. Why do you think I made this word possibility bold and red? Because after sampling we go into probability, because it is on probability. No, the method is of chance selection. What is this called? This is called as method of chance selection. as it depends on probability. Correct. It depends on probability. That's why it is called chance selection. It can so happen, that you end up selecting only those people where their probability, that's what I'm saying. It can so happen that you might end up selecting those people only. You might get a data where only people's height is around less than 160. Possible? Random sampling, no? Random sampling, no? So problem could be that problem could be that we might end up getting. So this was taught to you. All this random sampling and everything has been taught to you. What is random sampling? What is, yes, you guys know this. So here we might end up getting similar samples. If I get similar samples, what will happen? What is the impact? If I get similar samples, what will happen? What do you think? See, you need to think. We might, there are variance and standard deviation might not be right. Correct, deviation will not be correct. My mean will not be correct. Because my mean will not be correct, my deviation will not be correct. Correct. So when I'm going to end up plotting the graph, I might not be able to get this kind of the right information. My project fails. So they came with the, as you said, systematic sampling. It is called, this is probability. So systematic sampling is, you can say it is non-probability. You have used some logic. Okay, systematic sampling would be you are using some logic. Okay, systematic sampling is like you are using some logic. Okay, so what can be a systematic sampling? Systematic sampling can be what? So out of 500, I need 50. Out of 500, I need 50. So every student, let's assume every student has a student ID. Every student ID divisible by 5. Or 50. Say every fifth student ID I'll take. Or third, I want 50 out of 500. 50 out of 500 means every 10th student I will take, looking at the roll number. Okay, so systematic, I can have a system. Every 10th student I will pick looking at their roll numbers. Like what? Like what? 1, 10, 20, 30, 40, 50, 60, 70, 80, 90, or you can start with 10. 100. Okay, and then I will again, what is this? This is 10. Then 100, 110, and so on. Okay, so this way 110, 120, 130, and so on. Okay, so this way I will gather whatever, so this way I will pick 50 samples. Okay, so here we are applying some kind of logic, right? Some kind of logic we are applying. Yes, so here the possibility becomes less. Now this is not probability. This is not based on possibility. Now you are having some logic. You can't call this as probability based. It is having some logic why we are doing this. Okay. The third one is stratified sampling. Let's assume that there will be males and female in your male and female will be there in your population. Male and female. Yes. Male and female. Say ratio is 60:40. When you picked sampling, problem with systematic sampling as such, no problem as such. You can take a systematic sampling approach, but people prefer to use stratified. They use stratified. Why? I'll tell you. Here the problem could be that you might end up getting more number of boys than girls. It could be. Possible problem. More students of a certain gender were selected. Okay, this is possible, no? 10th, 30th, 40, 50, 70, and only 20 and 100 were female. 8 were male. 20, 30 were female. Rest were, or 20, 30, 10 were female. 140, 150. Okay, they were all males. So this is not right, no? Correct, no? Is this correct? Is my sampling correct? Those highlighted in red are females. Those highlighted in black are males. Again, problem is that my mean will be different. Again, my mean will be different. So they came with another technique called as stratified. So if your male female ratio is 60:40, no means Sagar, no means not understanding, or you agree that this technique is not right? Sanjay, you want to say something? Sanjay, you are saying no. Is there something that you want to say? Okay, so male and female, if they are in the ratio 60:40, but due to your sampling technique, you got 75:25 male is to female data. This will again lead to incorrect inferences. Because we are doing inferential statistics. What is the meaning of inference? Inference. A conclusion reached on base of evidence and reasoning. Okay, we are we are we are actually taking evidence, and by using calculations we are doing reasoning. Correct? Evidence drawn by from evidence, conclusion drawn by evidence and reasoning. This is inference. Okay, inferential technique, right? We have gone into inference. So we are doing here inferential statistics. So inference is, and that is exactly what we want to do. So we are actually by 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 going to each and every people, each and every person, 50 people, we are doing sample 50, sample 50, sample 50. Sample is 50, 50, 50. We are actually gathering no evidence. We are gathering evidence. On the basis of that information, we are reasoning also ki bhaiya, the height is going to be this average. Correct? So now how does stratified works? Stratified works like this. What it does, look at this diagram and understand. This is our population. So there are three categories: male, female, say transgender. Okay, male, female, transgender. It's a good example. Okay, so this is 10, this is 8, this is 6. Okay, so male, red, blue can be male, red can be female, black can be transgender. Okay, so this is when you look at the population, and even if you apply a statistic, what do you say, systematic approach, 1 2 3 4 5 6 7 8 9. So in the first 10 you have 2 blacks, 11 10 11 12 2 reds. So you might end up having more blacks, whereas the population of black is less. Correct? It is quite possible that even if you use systematic, you might end up getting more blacks than the other two. Agree, no? Say I might end up using a this of 4, systematic 4, 1 2 3 4 5 6 7 8, 2 blues, 9 10 11 12, third also blue, 13 14 15 16 17 18 19.
Just a quick info, guys. Intellipaat offers a data science course which will help you master Python, SQL, machine learning, AI, and Power BI. Get a data science certification from IIT Empowertak and Innovation Hub of IIT Madras. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height. So visit the course page link given in the description and take the first step towards the career growth with the data science course.
19 20, 2 reds, 21 22 20 24, black, 25 26 27 28, blue. Black is 1, 2 blues, 2 reds. Okay, so I got black 1, but that is not the ratio, na? That is not how the ratio is. 10 is to 8 is to 6. So 10 is to 8 is to 6 is 5 is to 4 is to 3. So I cannot use that logic systematic. Agree? So what they do they separate the population on the basis of the strata. They call it as strata. And on that strata, they will do a proportionate sampling. Now from here, we will use a certain logic. This is 10, 5 of this. So 4 of this, 3 of this. 3 of this, 2 of this, 1 of this. You can do that. If you want to do sampling here, then you can do 3 of male, 2 of female, 1 of transgender, like this. So that is how you will end up doing stratified sampling. Understood, everyone? Clear? Okay, so now do you want to see this programmatically? Do you want to see this in a program? Okay. Then from here, actually, from this story, from this story, we move into something called as the next topics actually are. So if you want me to continue the theory, I can continue the theory. If you want me to show you some program on these 3 samplings, I can show you. What do you want me to do? Or theory enough for the day? Now I'll ask you, what is your confidence level? First of all, you have taken the mean from the samples, not the population. What is our objective? Objective is to know the average height of the students at the university studying at the university for certain courses. Okay, you have taken 3 samples and are trying to guess the average height of the population. Okay, so population count is 1500, sample count is 150. This is what we are trying to do. Correct? This is clear? Now if I tell you, say you got average height 170 centimeters. What is your confidence level? If I tell you, what will you say? Confidence interval. What is the confidence interval of the average height of 1500 students, or in the other case, population? Did you get my point where my problem is? Do you get my point? Do you get my point? So I need to know between which interval my population mean will lie. I need to know within which interval my population mean will lie. This is called as confidence interval. Okay. So like, okay. So what happened? What happened here? Each sample is likely to come out with a different mean. 3 samples, 1, 2, 3. Right? This is clear. I took sample. There's a population 1500 people. I took 3 samples. 3 samples would come out with 3 different mean. Now it is very useful to know a range in which the true value will lie with high probability. Basically, I want to know what will be the true mean of the population with high probability. Okay. So the other person might say that so the confidence. So I will say, give me a 95% confidence interval value. Give me a 95% confidence interval value. What is 95%? That means what I'm saying? If a confidence interval is of 95% is given, one can be sure, can be 95% sure that the true mean value lies within that interval. Okay, so you can have so to calculate the confidence interval, what you need to do is you have a formula, confidence interval formula. Okay, so to calculate the confidence interval, you have a formula. This is your confidence interval formula. So I want a range. So X is the sample mean. N is the sample size. That is, we have taken 50. Sample mean could be 165. Plus minus indicates the lower and upper limit of the confidence interval respectively. Okay. So we had a sample mean. What was our mean here? Mean was 164.6. Mean was 164.6. Okay. What was our standard deviation? 6.2. Standard deviation is 6.2. Okay. What was sample size? Sample size is 50, right? We discussed now 50. Actually, in reality, it is 10. I agree. In reality, here we have taken sample size 10. But actually, in our project, we have taken sample size 50, no? We are going as per the project. We are just taking those reference values. Okay. You got my point? What I'm saying? as per our project sample size is 50, but we are just taking these values because where I'll get 50 numbers, no? Okay. So my sample size, you got it? No, why I'm not taking 10? If you want, I'll take 10, whichever you say. But it will not then go with your project here. This project is now in flow, no? Okay. So we'll take sample size as 50. Now what happens? Now what we have the mean, we have the standard deviation, we have sample. What is the Z score? What is the Z value? So the Z value is a standard value. It is available on the internet also. Okay. What is the standard value? Yeah, I think it should be 150 because we are taking the mean of the sample, because we are trying to calculate the confidence interval of the sample, and sample size is 150. I totally agree. I agree that the sample size should be 150 because out of 1500 we have taken 150. Okay. Yeah, good point. So now this confidence interval, no, it is available on the net, and it has they have generated a certain value. It is called as a Z table. Okay, it is called as a Z table. If you want Z table, okay. So if you want 95% confidence interval, then it will be a 1.96 multiply by 1.96. If you want 90% confidence, 1.645. You understood? Yes. Now, if I have to use this formula, confidence interval is equal to is what? You can take 99% also. You can take that also. Generally, people don't go for 99 because how it can be 99%? Do you think? People go for 90 or 95. They generally don't go for 99. Okay. So now let's say we are going for 95%, no, accuracy. Yeah, range will also be large. Range will also be large. The confidence interval also will be large. So what is the formula? Mean, that is equal to 164.6 plus what is the Z value? 95%, 1.96 bracket 1.96 into what is my standard deviation? 6.2 divide by square root of 150. Am I right? Am I right? So this is the confidence interval upper range. Okay. And confidence interval lower range is what? So can you say you can take 90%? If you take 90% multiplied by 1.645, this is 95% confidence interval. 95% confidence intervals. What is 90%? Let's see what is 90% confidence interval. Now let's see what is What answer we get for that? Interval 90%, 90%, 1.645. 6. No, 95 is, acha, sorry, here. 1.645. So slightly lower value. It is getting multiplied by a slightly lower value. So it is, the difference is coming closer instead. That means the upper layer and lower layer are coming closer to each other. Okay. Why? I don't know. It is mathematics. 95% confidence interval and 90% confidence interval. I'm just applying mathematics. I'm not doing anything. Whatever it is in front of you. 6.2. Yes. Standard deviation divided by, yes. So standard deviation confidence interval. Because hardly there is any difference between 1.64 and 1.96. If we take 99%, there is a, what happens if we take 99%? Am I doing some mathematics incorrect? Because this is now the difference is increased. Correct. He's got a point. Saket has got a point. If you want to be 99% sure, your range will be bigger. Correct. If you want to be 99% sure, your range has to be bigger. If you have to be 95% correct, your range will shrink. You are absolutely bang on right. Okay. So we'll put this statement here. Yes, you are right. Yes, I am going to share the file. Okay. Now, there is another parameter called as Z score. This is for the population, right? The population, this means 99% sure. This means we are 99% sure that the true mean height of the population will lie between 163.3 centimeters to 165.9 centimeter. This is our bottom line statement. Okay. Okay, I can't take Z square today because I need to explain to you what is standard deviation. Standard deviation. Okay. So this is where we'll stop today. I think we have. So we did now upper range because the formula has plus and minus. No, here. Iqbal, who was it? Revti. Revti, we need a range, no? The range will always be plus and minus. That is why we have got upper range and lower range. You got my point? Okay, I'm just hold on for a minute. I'm just sharing the file. I'm just sharing the file. Why it did not go? Statistics, it did not go. Why it's not going? Excel file does not go. Okay, wait. If it does not go, then wait. I'll convert it into, I'll zip it. Yes, I'll recap. Okay, just a minute. Okay, sent. Everyone got it? Please check before I do a quick recap. Okay, so how, from where we started our story today? Such a big journey, 3-hour journey. Okay, so we started with different types of data. Okay, some said qualitative, some said quantitative. So we finalized to categorical and numerical. In categorical, we had nominal and ordinal. In numerical, we had discrete and continuous. Then we tried to understand the different types of data. Then we tried to understand different types of data, not just in characteristics, but also in nature. Like what kind of data? Structured data is rows and columns. Semi-structured is HTML, XML. Unstructured is Twitter, Facebook. Then I explained to you your journey. What is your journey? How big is your journey? Okay, you are at second step, third, fourth, fifth, sixth, long way to go. I gave you slight information about different things. Then I explained to you the central tendencies. Mean, what is mean? What is median? What is mode? Then I explained to you the difference. What is variance? We have variance, but from variance we get standard deviation. Why? What is the importance of standard deviation? From standard deviation and all this central tendencies and descriptive statistics, we came into inferential statistics. What is inference? Baba, inference is a conclusion reached on the basis of evidence and reasoning. And a conclusion reached on basis of evidence and reasoning. So we need to do reasoning. Okay, we need to do reasoning and we need to have evidence. We know the concept mathematically. Descriptive statistics, we know how to describe a data, but how to collect the evidence, how to give a proper, after collecting evidence and analyzing it, how to give the reasoning and get the inference. Then we took a scenario where we took the number of students. We want to calculate the height. We took samples. We saw different types of sampling techniques: random, systematic, stratified. Random sampling is possibility based. It is called as method of chance. Then, but it has a problem. We might end up getting similar. Then we have systematic sampling. We might end up getting, again here also we might get a certain pattern. Might not be similar, but a pattern. So here also there is a problem because we have variety of people. We don't have same kind of people. So we came with stratified sampling. In stratified sampling, how does it work? It works like this. Then from there, we took the objective. Objective is to know the average height of students studying at the university. So we took 3 samples. You have taken 3 samples and we are trying to get the average 3 samples of 50. Then we have a population count of 1500. We took sample count of 150. Average height, we are saying it should be 170 centimeter. Okay, here also we are going to come into hypothesis. From here your hypothesis will also come. So what is the confidence interval of the height of 1500 student? We need to know from my interval in my population, where does it lie? Baba, where does it lie? No, we took average height as 164.6. Okay. So then we checked, Baba, where does it lie? Where does this information lie? We have a confidence interval. We calculated the confidence interval. Then our friend helped us understand that concept, that why it is shrinking and why it is moving ahead. Okay, 99% if you want, then the variation should be higher. If you want 90% variations should be lower. So he helped us understand that point. And that's how we came to the conclusion of confidence interval. Okay. Being active on Kaggle definitely helps. Saket. Stratified sampling was, I have more of male, I have male, female, transgender in a ratio. So my sample also should be in a ratio, no? It cannot be 10 of male, 10 of female, 10 of transgender. My sampling technique also should be in ratio, Akshata. You got my point? That's what I said. I have 10 of male, 8 of female, 6 of transgender. I have 10 female transgender. So my sampling also should be 5:4:3. Correct? We should ideally use stratified to get a better analysis. Always use stratified. Very much a technology which is going to come up. Okay. What your chat GPT, and everyone knows what is chat GPT? Everyone knows what is chat GPT? Yes, you guys use chat GPT? Yeah. So it is based on transformers, and transformers is based on autoencoder. Okay. So this is going to be your future. If you have to catch up, I mean, stats is okay. Stats is used not so much. Okay. Stats, but knowing these models is very important. Okay. All these models, object detection is detecting the object from the image. So this was another thing I thought I'll share with you. Then what we did, we went into the central tendency part, where we I think your programming is done. This is your course. Now I think your course is like this, right? Python programming, statistics, ML, NLP, DL. This is how your course is designed, no? I don't know about your course. I just know I've been asked to take your inferential stats. Okay. I don't know what else is there in your course. Everyone, it depends. Some people take the full course. Okay, like this. Some people take in parts. So it depends on what you have taken. So I don't know, when you're asking me what is covered in Python programming is different. It's only a programming language. Now using Python programming, you are going to code in machine learning, NLP, deep learning. Okay, so that is how it is. They are three different, I mean, okay, so using that technique, like how, yeah, that is one thing. Now in machine learning, you will learn how to use pandas, NumPy pandas, and model building. That same knowledge you will take into deep learning. You understood? So these are building blocks. Like you'll have to learn to do bookkeeping, or you need to understand what is debit and credit to become a commerce student. Okay, so like that, to know how to matlab, do programming in machine learning and deep learning, you need to know Python. You understood what I'm trying, how I'm referring, Mahesh? You got my point? Okay, so like that is basic. मतलब किस tools, how are you going to do it? क्या program लिखोगे क्या? And so now I'm going to show you how in statistics I'm going to use Python. Statistics I'm going to use Python. Today we are going to do coding. Okay, first whatever I have taught you, this mean, how to calculate the mean. Then median, how to find the median. Then mode, how to find the mode. Then variance, how to find the variance. How to do standard deviation. Then the population, creating a population, creating a sample, and creating these three different types of random and systematic and stratified sampling. Then I will, after showing you all this, I will show you how to calculate your confidence interval and how this confidence, and then I will show you how to build this kind of a normal distribution graph. Okay, how this normal distribution graph is generated. I'll show you all this in Python now. See, this is the theory part you learned, right? Last time we learned all this, isn't it? what is standard deviation, mean, median, mode was easy. What was standard, what was variance? The amount of data that is varying. So this is your variance graph. Actually, this is your variance graph. How much is the data varying, Baba? Data is varying from this point to this point. So much data I have. It is varying from this point to this point. Okay. And standard deviation is how far it is from one standard deviation to standard deviation. So what this guy is telling me, 63% of the data, 68 to 70% of the data is within one standard deviation. How far am I from the mean? All the time, the question that will be asked to you is how far are you from the mean? So your answer will be in one standard deviation away, two standard deviation away. But from where that standard deviation has come? Standard deviation has to be calculated. So we calculated the standard deviation. And the Z score is how far a point is away from the mean. The Z score always measures how far a value is away from the how many standard deviations away a value is from the mean. So this is Z score is how many standard deviation away a point, a new point or new data away, new data is from the mean. So the answer has to be in number of standard deviation. Okay. So this way we have to see all this in coding today. Coding. Okay. First we'll do the coding part. Then we will go into the next part. Okay. Everyone remembers all this? Everyone who has joined? So how I had told you about this confidence interval and the lower range and the upper range, all this calculations and all, everyone remembers? How we discussed about what is random sampling, systematic sampling, stratified sampling. Okay. And then we had taken this example, right? That we have a total of these many people, but we took these many samples. And then because of these samples, so this is a population, large data. We take a sample from it because, yeah. So basically, what happens, no, Tejas, confidence interval is not for the mean. It is to let me know between how much, what is the range in which my population mean will be there. You got my point? Okay, Tejas. Confidence interval is what is my low and high. Low, this is my high point. So I took 3 samples. Yeah. So sampling is I've got a full population. I cannot take the mean of the height of the full population. What was our requirement? Baba, what is the mean height of the complete population? Here we had that, right? What we wanted to calculate, what was the problem statement? Average height, find the average height of students studying in Pune University for the following courses. This we cannot do. This we cannot do by just going to everyone. Isn't it? That's what we had discussed. No, if we go to everyone, then we cannot do. It's practically not possible. But we can take certain sample of people. So if out of 1500 people, I'm taking sample of 150 people. I'm going to take the mean of these people. Okay. Once I've taken mean X, say this is mean. Okay. Let's take this as mean X, Y, Z. So what this is, he's saying, Baba, this is one is X. He's saying this is X.
Just a quick info, guys. Intellipaat offers a data science course which will help you master Python, SQL, machine learning, AI, and Power BI. Get a data science certification from IIT Empowertak and Innovation Hub of IIT Madras. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height. So visit the course page link given in the description and take the first step towards the career growth with the data science course.
X. So this is X. He's saying this is X. Y. Z. So I'm trying to tell, so I'm going to find a confidence interval. Using these values, I'm going to find a confidence interval between which I feel that my population mean is, because our problem statement was that I want to find the population mean, no? Agree now? Everyone now able to recollect? So confidence interval gives a range in which the true mean shall be present. Okay, true mean, actually it is an incomplete statement. True mean of the population shall be present with a certain probability. Okay, with a certain probability. So when you say 99% probability, then the range was higher. That one of my friend, who was my friend there, who told me that the range will be higher because we want that it's 99% confidence we want. Yeah, that is the reason why. Yeah, that is the reason why the range is more, because I want to be 99% confident. 95% or 90% confident, the range is smaller. Ha, Baba, it is going to be here, between here only. But generally, if you'll see, no, the range is very similar on similar terms. That my mean. So after doing all this, I can clearly say that my mean will lie between possibly 163 and 165 for 1500 people. My inference after doing all this mathematics, my final statement is, Baba, after doing all this, I will say, looking at the above, statistics, we can infer that the mean of the complete population of 1500 students across 3 streams will lie between 163.5 and what was the other one? 163.5 and 165.5. Okay, 165.5. Where is my statement? 165.5. Okay, so actually this statement should come down. Okay, so this statement, nothing, Iqbal, we just did a quick recap. Okay, nothing we have done. We are just doing a quick recap, and this is my final statement. Correct? Now everyone recollects everything? Yes? Finish. So this was what we wanted to infer. This is what we wanted to infer. This is what was our work. Now I got my mean, say, and now I am going to say, Baba, how many standard deviations? How far are you? Baba, say you as a you, it's like standard deviation away. So let's assume in this diagram, no, this diagram I can plot in a different way just for you guys. Okay, don't laugh at me. Uh, Pulse I. Okay. Images. Just give me a minute. I'm searching an image for you guys. 1, 2, 3. Yeah, I got it. Chalo guru. Copy image. Okay. So now this same you will only, Iqbal, you can give mic access to yourself. In join with audio or something like that option will be there. Iqbal.
Okay, but the range are not same. What you have wrote here.
Yeah, so we can always take a for 95% it can be this, nor you can, in general, even if you take an average of all this, you will get 164.5.
Okay, okay, okay.
Okay.
Yeah, okay.
Thoda to we will also apply. No, not everything will come from maths, but
Yeah, right.
statistics is that it will be between somewhere here. So let's assume the mean is 164.5. Looking at the stats, we'll say it is 164.5. So now I was saying how to infer this.
Hmm.
What is
Okay.
this? Okay. So
And what
now
is this empirical rule?
that's what I'm telling, no?
Yeah, and I want definition.
Sir, you let me talk, no?
Okay, sir. Okay.
Okay. So why I have taken this picture? Because it might be more easy for you to analyze. What is this empirical rule? We'll come to the empirical rule. Okay, don't worry. We'll come to the empirical rule. You will get the definition, everything. Okay. But what is the purpose? Baba, what is this telling me? Okay. So this mean, no, this to just make thing easy for you. This mean is this point. Okay. So ideally the population, say according to me, the population, looking at these figures, this population could have been 164.5. Okay, let's assume we get from the population. We will do it programmatically also. Should have been 164.5 according to, we did so much inference because we never took the whole population only. Then how can I say it is going to be this much? I have to work on a range. But the data helps me get this mean. Okay, say 164.5. Now one standard deviation away. So if your point, if your new data is 155, 165 or 167, so you will say it will come somewhere here on this point. Okay, I'll take another. Okay, on the right hand side. Okay, the new point will come, say, okay, say this is your first point, this is your second point, this is your third point. So this is your first line, second line, third line. Okay, this one. Okay, third line. Now, if you get a new point, new entry into this data set, new entry. Okay, so a new person joins your college and his height seems to be here, 167. Sorry, 167. So how many standard deviation away he is from the mean? This is your first deviation from the mean. This is your second deviation from the mean. This is your third. So from the target, how far is he? 1. Okay, 1. So there is a standard deviation. Okay, then if you get another, so depending on what is the standard deviation value, here we had calculated the standard deviation value. Isn't it? What was the standard deviation? 6. So basically 164 plus 6, 170. If he is around 170, then he is in the first standard deviation, right? You understood? 170. If he is 176, then where? If he is 176, then, so this is your 176. 164 plus 6.2, say around 170. Plus in this 176, because standard deviation is 6. So 176. Plus the third one, 176 plus the border, the third deviation. What is it going to be? 176 plus 6 again, 182. So this is how you calculate your, so what I'm going to say, Baba, the whole data set is coming between this range. So what he's saying, that 99.7% of the data will come always lie between your 3 deviations. 95% of the data will lie between 2 deviations. And 70% of the data will lie between your first deviation. Now you understand? And Z score tells me how many deviation away the new data is. Everyone understood this point? No rush. There is absolutely no rush. I'm just trying to make you understand the how to infer the this empirical rule. Okay, so empirical rule is that only, that first he's saying if the distribution of your data is this way, if the distribution of your means, you will not just take one mean or two mean or three mean, you will take lot of means. Okay, when you plot the mean, no, the graph looks like this. And now this is your center mean. Then what he says, that Baba, this new data has come in. How far are you? Like if you are working on a bullseye, if you are working on a bullseye, when you hit the bull, when you hit your target came here. So how far am I, Baba? So there has to be some way, no, of finding out how far I am.
Yeah.
So this is the way we find out how far I am from the mean. So then only why we are doing this? Because this impacts the accuracy of the model. When you will do machine learning, you will realize that if there is one data set like this, okay, if you have a data set like this, understand why we are doing this, why this is the need. If you have a data set which is like this, I'll change the color. Everyone, please listen, because this is very important. Why all this effort? Okay, you will not use this level of statistics. Yes, Sumit. So say you collected data. Okay, you are working as an insurance agent. Okay, and you collected data, Baba, according to age. You collected if the person has insurance or not. Correct? Got it? Have insurance. Okay, so according to a certain age. Correct? Let's assume this is 20, 30, 40, 50, 60. So 20, I'm writing to 20, 30, 40, 50, 60. What I got, no, after, say there are two scenarios. Listening, Iqbal?
Yes, sir.
Yes. And what about others? Everyone is listening? Okay. So I got two graphs. I got two graphs too. Okay. One is when I plotted the graph, no, I got something like this. Okay. So when I took the mean of all these values, no, when I took the mean of all these values, no, it came to be somewhere around here. Okay. Because these people will pull the mean, no? These people will pull the mean. If
Yes.
these people were not there, then the mean would have been here. But these people will pull the mean. Think logically. Okay. It's all force, no? Now this mean, now a new person comes with age. Say a new person comes with age 52. Looking at this data set, can you say he should have an insurance or not?
No.
He should, na? These people are already having, no?
Yes.
So he should have he should have, no?
Yeah.
He should have. Okay. So because your mean will tell you, your mean is also around 50. This guy is 52. So you'll say, yes, he should have. Mean is telling you, yes, he should have. Though these people are wrong entries or they are exceptions. Okay. Now I have another graph. I have another plot. So now you tell me, if you get an entry of a person who is 32, new entry, how will you find out if he should have or not? It is difficult because your data is scattered. Because your data is scattered. So it becomes difficult to find out. Now your mean will be somewhere here. Here will be your mean. There is no good relation between X and Y. Here will be your mean. Now because your mean will be here, you will be 50% confident. He should have, not have. Here, because the data is scattered, your confidence level will be less. That is what we calculate in machine learning also. What is the confidence of that? What is the accuracy? What is the confidence? So you'll say, okay, 32 might be, might not be, might be, might not be, because this is, guys, scattered. How far is he from the mean? Okay, it could be, instead of 32, I should take the example of, wrong example. I should take, instead of 32, I should take 22. My mean is here. My new entry is here. I'm so far. Because I'm so far, my confidence level is also low, no?
Yeah.
Now you understood how pictorially it works?
Yeah. Yeah.
Yeah, because the mean tells me how far the new entry is. The farther I am, the more I am an outlier. Okay, so these points, no, anything beyond this and this, whatever points will go beyond this, no, that means what? For us, what is the situation? For us, the situation is, we said the mean is 164.5. Okay, understand, the mean I said was 164.5. I took standard deviation. I calculated standard deviation 6.2. I will take 6. 164 plus 6, 170.5. 176.5. 182.5. Any height beyond 182.5 is an outlier. Anything beyond 182.5, he's the statistical people will say this guy is an outlier. And when you will plot a graph also, no, this guy will look somewhere here as out somewhere. Now everyone is able to understand. This is on the negative side, 164 minus, so this is 158.5. Then again 6, 152.5. Then this again 146.5. So what the empirical rule is telling me, 99 point, what is the he's saying 99.7 data will 99.7 percent of data will range between 146.5 and 182.5. After lesser than this and above this is all outlier. And how far is my new point? Say if my new point is 172. How far is my new point? Say my new point is here, 172, sorry, here. So my answer in statistical terms is going to be, I am 1 standard deviation away, or you can say I am between 1 and 2 standard deviation from the mean. Now you understood? Now the story is complete?
Yeah.
Yes? It will keep on changing depending on the mean. It will keep on changing depending on the mean, because your mean is here, no, P. This is your mean. And see, this is your standard deviation. Can you see this? Standard deviation. Only for normal distribution. The other distribution are skewed distributions. Okay. So the other distributions are skewed. So then they need to work on skewed distribution. Okay. So then what happens, no? So the other two types of distribution are this. One is a negative skew, positive skew. Skewed distribution, they are called as. Okay. This is normal distribution. This is called as normal distribution. But for skewed distribution, then you need to work on this data and get it right. Okay. In some programs, I have seen they apply a mathematical function called as log. Either they apply log or exponent on this data. np.log, they push this whole data through a function called as np.log or np.exponent. I'm not able to remember, but this whole data set, no, that the data that created this, no, this whole data is passed through np.log function, I think, or np.exponent function. I think log. Yeah. Okay. Then once they pass this through np.log, no, the distribution then changes. Not, see, this is all theory. Okay. Actually, it is slightly here and there, but then generally you will get a relatively better distribution on which you can work on. Now understood, everyone? The background and the effort and whatever. Okay. So now we ideally the more mean we take, no, the more mean we take, the better is the distribution. We get a better what you say, normal distribution. I will show you. The more mean you will take, no, the better distribution you will get. There was one website. I'm not able to recollect which website it is, but there was one website on which this guy had shown it. One person had shown it that the more mean you take from the data, and you plot it, the better you get the distribution. And even if you are not, then even then you are not getting the distribution, then there is problem with the data. Okay. Yeah, no, actually you won't call them as outliers. That data itself is like that. You have to correct the data. Outlier would be beyond this line. Beyond these 2 points, they are outliers. They are out, totally out. The data in itself is like this, that it is plotting like this. Okay. Okay. So now let's see how to do this in programmatically way. Okay. So then after doing the program part of it, no. So now once we do the program part of it, no, you will then, I need to tell you story before we hypothesis related to hypothesis, because tomorrow all the tests are related to hypothesis. All the tests that we are going to do, no, they are related to hypothesis. Okay. But before that, up till now, whatever we have done, we should understand program wise also. Okay. So I'll just take a glass of water. Give me a minute. So what we are going to do is, first I'll show you how to take random samples from a list. Okay. One, step by step. You just keep looking at what I'm doing. And if you have any questions, please ask. Okay. Sometimes when I write certain code, no, I get pink color warnings. The code executes, but I get pink color warnings. To ignore those warnings, I'm writing this code. I don't want to see those pink color lines. I don't know which statement might give those warnings. So now first we'll understand how to do encoding random sampling. So now, no, you watch. It is more important for you to see. This code anyway I will share with you. You can practice at home later. This anyway I'll share with you, no? So from our module in Python, you must have done a module called as random import sample. Okay. So it has, the module random has a inbuilt function called as sample. Okay. This function will help me do sampling, random sampling. Okay. So I'll create a list. Okay, I created a list and I'll say sample list 1 for 3 samples. I want 3 random samples. So he took 3 random samples. Random sampling. Okay. So random sampling is when I have applied, when I'm saying random, pick 3 samples from this. If I say 5 samples, any 5 samples he'll pick and give. Just like how now imagine the reality. In reality, that is what we are going to do. No, you have gone to the college. You have to pick 50 random samples, right? You have to pick 50 random samples. So you will go and you will just catch those people, no? So in program also, I should be able to catch things randomly, no? You got my point, everyone? What I'm doing? Okay. Yeah. So this is simple code. Yes, it will keep changing. You want to see? See 5 random. 5 random. So 3 random from 10. It will always give you different values. Okay. This random sampling is clear. Okay. Very simple. Now, the second example is systematic sampling. Okay. What is systematic sampling? Random values between a range, no? Between 1 and 5 only, you are saying. So then you have to use something called, no, this guy will give you any random values from the list that you cannot change. That you cannot change. It will take any random values from this list. Okay, that what you are asking for, it is something else. Like I'll show you in okay, you guys, this all this whatever is your query, no, you can get answer on the net also. But random sampling is from my population. So it's like, see here, this is my population. I should say this population. And this is my sample. Population 1, sample 1. So I'm taking a sample of 3. You got my point. So you're not, your question is, so this is my sample. I'm doing sampling, no? Population, this was my population. I cannot have a, say that I want only for this range of people only I'm going to take sample. This is your population only, no, full population. Okay. And this is your sample, isn't it? Now you got it. What is sampling, no? Now I'm using the word. Okay. Now the next one is systematic sampling. So again, I'm going to create a population. I'm going to create a population. Okay. That population I'm calling as data. Okay. Here. Okay. I've just created one data set. Yeah, I was typing, no? That's why I was not audible. So I've just created one data set. Okay. Now I want to use systematic sampling. Systematic sampling was what? 2, every third, every second, every third, like that, right? Systematic sampling was what? Equal distance, right? No? Every third. So what he did, he has taken the indexes between 0 to 14. Between 0 to the length of the data frame. For those steps, he collected the indexes. He put it into the systematic sample. And for those values, basically ilog means that value, those steps he collected. Simple way for those steps. So he created a list of indexes that I wanted between this range at the steps. I have given, no, here 3. So 3 went to steps. Every 3 starting from 0, 0, 3, 6, 9, 12. 0, 3. These indexes were stored in indexes. So if you want, you can do debug in PyCharm later. But those indexes for those steps were stored in indexes. So there's like that what fancy indexing or that concept like fancy indexing, no? That kind of concept this is. So all the indexes are stored into this. So this became list of indexes. You want to see what is index there in indexes? Because it is here. Local variable. So the list of indexes were here, and for those indexes, he put the data in systematic sample, and he returned the value. Clear now? Clear? Clear? This is systematic sampling. Very easy. I'm showing you very simple programs. Now, our problem, slightly difficult part, is the stratified sampling, right? Stratified sampling. Slightly complicated. So I'm going to create a data, say students, okay? Akshata, I will share this with you. Don't worry. I will share all this with you. Have you understood the, yeah? Everything, it's easy? Yeah? Okay. So now I will create a student data. No, at least I couldn't find. I could not find. It must be, but I tried to find. Generally, I don't take it so deep. But looking at the group, I thought that you guys you need to visualize. Once you are able to visualize, it solves the problem. Hai na? Okay, so this guy is going to pick two samples. He is going to group by the grade and pick two samples. Okay. So what he's doing, he's picking 2 of A, 2 of B, 2 of C. Is this sampling correct? So there's a simple code, group by grade and pick two samples. This is group by grade and pick two samples. Is this correct? Is this correct? No, because I have 5 samples of A. I have 5 samples of A. So my data set is 5:3:2. So how can my sample be 2:2:2? Where is the proportion? It is not proportioned properly, no? So now what they did, they have a simple function to solve this problem. Okay, the simple function to solve this problem is what he said. He took this code, same code, whoever wrote this code, okay? He took the same code and used a concept called as fraction equal to 0.6. So I got 3:2:1. What is this fraction equal to 0.6? So the fraction equal to 0.6 is very simple. He multiplied by the group. A is equal to 5. So 5 multiplied by 0.6 is equal to what? Around 3. It is 3. Okay. Then B is equal to 3. So 3 multiplied by 0.6 is 1.8. So he took 2. And C is equal to 2 multiplied by 0.6 is 1.2. So he rounded off to 1. Now you understood how he got this? It took me a very long time to understand what he's doing. Trust me. So this was, no, if you take 0.5, the multiplication will change. If I take 0.5, I'll get different data set. Yeah, group key equal to false, even I don't know. I'll have to check what it is. I also got this code from somewhere. Group keys equal to false means what? When calling apply and the by argument produces a like index to identify pieces. Add group keys to index to identify pieces. By default, group keys is not included. I don't know. I've never worked on it, but I got this code. If I apply true, then what happens? Oh, it is grouped them according to the grade. It's like a pivot. Yeah, it is standard code. Standard code. Okay, so it basically now group keys means it is pivot. It's applied a pivot table. It looks like a pivot table now. Have you worked on pivot tables? Yes, no? No, the better value of fraction, it depends on your data set. There is no better value of fraction, na friend. Because I wanted it in a proportion, no, Revati? My current data set is 5:3:2. If you think logically, see, don't go by just by mathematics. You have to use your head also. Your current data set is 5:3:2. So ideally your sample should be what? Can't be 2:2, no? Can't be 2:2. So if I have to take one from, if this is 1 and if this is, so if this is 1, I'm taking 1 from here, this should be 1.5 and this should be 2.5. Correct? Let's work backwards. So what this will round to? People cannot be 2.5, no? People cannot be 1.5, no? So this will round to 3:2:1. So now what fraction will give me 3:2:1? I have worked it out. 0.5 is giving me different answer. 0.6 is giving me different answer. You got my point now? 60%. 60% of the group I have taken. Because my distribution is like that. Confidence interval assumes certainty of population parameter falling in the given intervals. So in short, that is what population parameter means, population mean. Okay. For example, if a point estimate 10 from the sample statistics for the confidence interval, from the sample statistics for the confidence interval 95% falls into 9.5, we can infer that there is 95% certainty that the true or population estimate will fall in the same interval. So this is exactly what I'm saying. He's just putting it in a different way. Point estimate means what? I also did a point estimate looking at the range, that my point estimate should be 64.5. So he's giving this term, no? This term that this value that I use, no? 164.5. Looking at these values, I said 164.5. He's saying it is a point estimate. 1 point estimate you give. So here he's saying 10. From looking at the samples, point estimate is 10. So he according to him, from the sample statistics for confidence level 95% falls in 9.5 to 10.5 range. So this is the range that we also calculated. So for us, in our terms, 164.5 is the point estimate. And where does it lie? It will lie between, actually, for us, it is lying between 95%, 95% and 90% also, all the percents. Okay. So what is confidence interval? He's given the program, but actually I will do the confidence interval in a different way. Okay. I'm not doing it in this way. I'm doing it in a different way, the way we discussed. Okay. So let's stick to what we have discussed. What he's saying and what I'm saying is the same thing, but in different ways. Okay. So let's come to a program. So what is confidence interval? How we calculated? Let's follow the same steps that we calculated. Okay. What I'll do, I'll first create a population. Okay. So statistics functions, they are available in a package called as Skype. Import Skype stats as st. Okay, so st, this has the certain functions st, and there is one statistics module also, import statistics. I think he has written all that here. Statistics, Skype stats and statistics as s. Okay, and we'll also import numpy as np. Okay, what he has done, no, he created a population of 100 and took the mean, sample standard deviation. I did it in a different way. I think I have done it in a more logical way. Okay, what I did, no, I wrote a small piece of code to create a population, because think logically. I went to a certain college and I'm looking at the height. Height is going to be in a range, no? In India, height of female or male or female will be in the range between 150 and 200. I took 150, 200. You can take it in a different way. So I created the population. Create dummy population. Okay, I created dummy population. How? See, I said import random. I created one population. Empty list. And what I'm saying, for I in 100 values, and I'm saying n is equal to random dot rand int integer, and create a random number between 150 and 200, put it in n and append the population. See, normal, I am using normal Python to create a population, and then I'm saying print population. See, so I actually first I did this in Excel. First I did all this in Excel. Okay, and but then I was thinking how to do in Python, so I wrote this code. Now I have got 100 people, height of 100 students with random heights. Actually, in reality, this is what is going to happen, no? Correct? Correct? In reality, this is what is going to happen, no? We have to think how in reality it is working. Now, for my reference, because I have the population value, I would generally not have a population value. Correct? You agree? Do you think I will have 100 numbers or 200 numbers with me? I will not have, but I'm creating a dummy population, right? You got my point, what I'm saying? Everyone with me? See, I'm creating a hypothetical situation, okay? Because I cannot actually go and do it myself. So this is a college dummy population is there. I don't know, okay? And for reference, what I'm doing, I'm just finding out the mean, okay? Population underscore mean is equal to np dot mean. This for my reference. Append is each value append into the list, no? It is Python coding, appending, adding to the list. This is an empty list, adding to the list. Okay, and what I'm doing, I'm taking the population mean of population. This is for reference. So for reference, the mean of the population is 176. Okay, this is for just for reference. Now, what is the actual how you are going to actually do it in reality? How you are going to do it? Okay, so I'll give it a name, height underscore 30 underscore 1 first sample is equal to random dot choices from the population, comma k equal to 30. Okay, k equal to 30. So 30 random samples from the population. Understood the code? Understood the code? So you guys are learning, no? I have 77 in the class. Only few are talking, but I am assuming that others are also learning. It is very simple. Okay. So print, I got my sample. Baba, you went. Tell me your height, tell me your height, tell me your height. What I have not defined? This is direct list. It will give me a list, no? It will give me a list, no? Here random sampling we did, it directly gives you a list, no? Sample gives you a list, no? We are directly doing random sampling, no? You are also going to do that only. You are also going to do that only. You will go, Arey Baba, tell me your height, tell me your height. 30 people, you will take your height of 30 people, no? Correct, no? Correct. This is not systematic. This is random sampling of 30 people. This is not systematic. I am doing random sampling of 30 people. Any 30 will come. Every time this will change. You try that. Okay, currently I have prepared according to random sampling. You can try another sampling method also. Okay, you try all that.
Just a quick info, guys. Intellipaat offers a data science course which will help you master Python, SQL, machine learning, AI, and Power BI. Get a data science certification from IIT Empowertak and Innovation Hub of IIT Madras. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height. So visit the course page link given in the description and take the first step towards the career growth with the data science course.
What we need to understand is the I don't know if random samples takes that parameter of how many. Yeah, you can do sample also. Sample and yeah, you can do that. Sample of 30. Okay, let's try that also. Yeah, it will give you the same thing. 30 samples. Okay. So let's take this code only. Let's take this code. Let's put it here. Okay, fine. Works. Done. Random sampling. Yes, what we learned, we are applying here. Okay. So this example I had prepared long time back. Then I recently found example of random sampling stratified. So little bit here and there. Okay. So I got my standard deviation. Okay. Standard deviation I got 15.5. So what will be my first standard deviation? 15.5 plus and 15.5 minus. Both sides, plus and minus. Okay. So I got my standard deviation. Now what he is saying, this is this term, no, this term. There is something called as a standard error. Okay. If this term wouldn't have been there in the formula, if this term z into s divided by 1 by n, my mean would have been the mean of the population. You got my point. Think logically. Okay. My confidence interval I wouldn't have needed the confidence interval if this term was not there. If I remove this term, what is my confidence interval? The mean. Correct? Everyone agrees? Everyone agrees? This term is telling me how much my error could be. This is my mean. This term is actually telling me how much my error could be from here to here. You understood? That is why they call this as error. In statistics, see, I am also coder. I have also learned from hearing things. Okay, I am not a statistician. I am a full-fledged coder. I am a machine learning coder. Then I have learned how to relate things backwards. Okay, so if I don't have this, if I never had this formula, if I never had this, my confidence interval would have been my mean. Okay, straight. This guy is telling me how much that mean can move around. This is the error, plus and minus. You understood how much the error can move around? This code is like, take a sample numbers from 100, take the mean, take standard deviation, take the error, get the whatever ppf, what is that, confidence interval, multiply it. So whatever I had taught you, they just they have put those formulas and they have shown the distribution plot. I just tried to give this whole thing a meaning. You understood? If you will run this code, if you'll run this code, you will get this kind of a graph. Okay, we will also get this kind of a graph, but with a meaning. I tried to relate it to reality, some kind of context you have to give to the example. So I tried to give context to that example. I could have just taken you through the slide. Frankly, I can take you through all these slides without telling you story. I'm trying to tell you story so that you remember it. You got my point? So you will remember the confidence interval and everything. Correct. Either it is correct or it is incorrect. Either the statement is correct or incorrect. Correct means what? Correct means what? There is something called as null hypothesis. Null hypothesis. Null hypothesis, I've made a statement. I'm going to do some test on that statement using the data, and then I will decide. So my null hypothesis would be that yes, the mean height of the population is 165. Okay, and the alternate hypothesis will be, what is alternate hypothesis? Not 165. Correct. No, the mean height of the population is not 165. Okay. Okay. So now I'll tell you one story. Again, story in a story, so that for those who did not understand. Okay. This was one series that was there on Netflix. Are you everyone listening to the story? 5-minute story. So this was a series. Okay. So how many of you don't understand Hindi? How many of you don't understand? Everyone understands Hindi? Because Gulam is saying Hindi mein sunaiye. Okay. 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 So there are people who don't know Hindi. Okay, fine. I'll tell you, I'll say in both the languages. Okay. I'll say in both the languages. Okay. So what happened, in this series, in this series, what happened? That the governor of Andaman, okay, I will say in Hindi also, the governor of Andaman has decided to keep a fair. अंडमान में एक मेला लगाने का सोचा है गवर्नर ने. Okay, so the governor of Andaman has decided to keep a fair, मेला Mela in Andaman. Okay. So many people from different states came to Andaman. Many people from different states came to Andaman. बहुत लोग अंडमान में आए. So there was this doctor, एक doctor थी. This doctor. Okay. She was running a hospital. एक hospital चला रही थी वो, ये doctor. And suddenly a few cases came. ऐसे कुछ cases आए. Few cases came where they were getting rashes on the back of their head. Okay, they were getting rashes on the back of their head. They were getting fever. तो पीठ के पीछे कुछ खुजली जैसे निशान हो जाते थे and उनको fever आता था. And then after a few days they used to become normal and they used to discharge them. तो कुछ दिन बाद वो normal हो जाते थे treatment के बाद और discharge कर देते थे. And then after a few days they used to understand they have died. The average height of Indian male is 165. The average height is not. Okay. Now, if it is less than 0.05, what does it mean? Let's take this example. Okay. If it is less than 0.05, what it means? What is the statement? Since the p-value is less, we reject the null hypothesis. Reject. What was the null hypothesis? Average height is. So it is not. So that is what is happening with us also, no? That is what is happening with us also. Now we are also, what is the value? It is 0.01. For us, he is giving us a value of 0.1. So according to him, we cannot reject the null hypothesis. According to him, we accept the null hypothesis, and it could be because they are very close in number. Okay. Whereas if I take this same example and I run it here, okay, it is giving me less than 0.05. So naturally, it is not 175. It is close to 165. Even the data is saying the same thing, no? That it is not 175. This mean is not equal to population mean of 175. We have to reject the null hypothesis, and it is not. We have to accept that it is not 165 or 175, because now here what is my hypothesis? It is not. Now here I'm checking with 175. You'll get confused. The more numbers you play with, the more you'll get confused. Okay. So let me just remove this line. I'll remove this line because this will only confuse you. What I tried to see is what is my p-value if it is when I'm comparing with 175. But the more you will play with it, the more you will get confused. Okay. I'll keep it for now, but let's do this one. Okay. What is this one? What is our condition here? Let's do fresh. Okay. We have to check whether the mean height of adult male in both the school is same or not. It is very difficult for your mind to get tuned. Huh? Okay. Again, I will write this statement. Everywhere I'll write this statement. Okay. So that we don't get confused. Okay. So now I'm taking one population _1. If you concentrate, you will understand. So we need to get the variance of that particular. First, we need to get the variance of the first height. And second, we need to get the variance of the second variance. We have discussed variance. Okay. So we need to get the variance. So we got the variance. One is 237, one is 174. Okay. Now we want to perform the test. Simple test. Okay. This statement here. What is it saying? Take both the samples. Take both the samples as my input and check if the variance are equal. Are they equal? Are they equal? No, they are not equal. That is what your p-value also is saying. It is less than 0.05. Less than 0.05 means I have to go with the alternate hypothesis. The mean are not equal. We reject the null hypothesis. We accept the null hypothesis. This is correct, no? It's working correct? Yes, understood. See, if you will start playing now, you try this, you try that, even I'll get confused. Let's understand the straight thing first. Okay, so this is very simple. T-test. This one is also very simple, the T-test. You make a population. If you want, we can make this population here also. This same thing we can do. Make this population. Yeah, actually they asked us to check the variance. The code for variance is here. Here. Simple. np.where. Okay. np.where. So I'm not just showing you the formula, but I'm also showing that the variants are actually not the same. Correct? No, I'm trying to join the dots. Correct? See, now I've got a mean of 176 because I created a new list. And I'm saying population mean is 165. I'm just showing you the one t-test. Okay, I'm showing you the one t-test again. I created a new population. From there, I picked 30 people. I took the mean. See what mean I'm getting? 176. Okay, I passed the whole population, whole sample. I've passed the whole sample and checking with the population mean of 165. Is it equal? It's not equal, no? Can you see? Sample mean is, that is the reason why the p-value is less. So we reject the null hypothesis. We have to accept that it is not 165, which is true. It is not 165, it is 176. Okay, got it? So this is how I have done the 2 sample t-test and 1 sample t-test. Now we have something called as paired sample t-test. So you don't even have to refer the slides. I'm writing everything, okay, for you. So if you want to refer it later, now you can just use this. Okay, so this is the paired sample t-test. Okay, in this again, I will write this statement, okay, because even I get confused. Since p-value is less than 0, we have to reject the null hypothesis. That means if the p-value is less than 0.05, they are equal, otherwise they are not equal. Okay, now what he said, he's taking one sample between 135 and 170, other sample between 145 and 180. Okay, so let's take that and test it. Okay, same code. I'll waste your time typing it. So sample female 135, sample female male. The value is less than 0.05. Correct? Obviously, it will never work, no? Because female height he has given less, male height he has given different. Okay. Now, just one. Can I try one thing? Can I try one thing? Guys? Okay. So what I'll do now, I'll just tweak this. I'll tweak this. Revati, these are used to check if the sample you have taken is right or not. Okay, because you cannot in real time know if you are going to learn. If I take same, if you are working on a project right from the beginning, okay, on a project where you have to start with data collection, then you will need this, that the sample you have taken is right or not. You got my point? This is just to let you know. So I'm taking 2 samples but from the same range. Interesting, is right what I'm doing? You understood what I'm doing? But but because it is random sample, no? Then what he does? Greater than 0. See, that means they are equal. Can you see? Everyone saw? I took a different range. It is given less than 0.05. So the means are not equal. I've taken a same range. It's almost the same. Can you see? That means the means are equal. Everyone understood what I've done? What tweaking I did here? Everyone? Understood? No, why I did this? I just wanted to check what is happening with the p-value so that you get confidence on the p-value. Okay. Yes, in correct. Iqbal is correct. In the t-test, I am able to get the p-value directly. Whereas in the I don't have to calculate. In the F test, I have to calculate this factor. This F is a factor. Factor that is this variance divided by the other variance. And that value I'm passing to this particular formula. Okay. Okay. So these are two different types of tests. One works on mean and the other works on variance. Okay. Any questions on this? P will only tell you, no, Gulam, only P value will tell you if you have to accept the null hypothesis or not. So what was the null hypothesis? The variance are equal. The alternate hypothesis, the variance are not equal. No, they are random samples, na Sonali. They are random samples. How can I make one sample where they'll be equal? Then your population has to be equal. This I've taken data from one population where it is 150 and 200. Okay, you want me to check? I'll make the same population here. Sonali, if p value is less than 0.05, then we have to if p value is, what is the condition? P value is less than 0.05, we reject the null hypothesis. If it is greater than 0.05, we have to accept the null hypothesis. So if it is less than 0.05, we have to reject the null hypothesis. No, what is the problem? I'm not able to understand why your guys are getting confused. This guy, I took the sample from here. I took the sample from here. Okay, who is it? Please interpret here P to accept or reject. What is my statement? The variance are equal, the variance are not equal. Okay, what is the condition? Since p value is less than 0.05, we reject the null hypothesis. P value less than 0.05, we reject the null hypothesis. That means if p is less than 0.05, we are going to reject the null hypothesis. Let's go through this statement first before I proceed. ANOVA test. ANOVA can be seen as an extension of t-test. While the t-test is used to compare means between two groups, ANOVA is used to compare means between three or more groups. That means the means of across three or four groups. So this is basically these are the means of those rats. Okay, after eating food at food 1, this was their mean. Food 2, this was their mean. Food 3. So this is how because 1, 2, 3, 4, 5, 6. No, they 3 different kinds of food are tested on rats for 6 weeks. For 6 weeks, this was the mean of those. Say the group of rats, we are assuming that the group of rats are of 10 each. Okay, we are assuming here that group of, there are 10 rats in each group. There are 10 rats in each group. Okay, so when for the first week, the mean after eating food 1 is 8. For the second week, the mean after eating food of this is 12. The third time, so that means this is the mean of those rats for 6 weeks. You understood the data, everyone? Everyone understood the data, because that is important. Okay, so now what he's trying to say, we have to just check the p value. Okay, what is the p value? Let's check the p value. So once I run this, what is the p value? It is less than 0.05. Less than 0.05 means what? We have to reject the null hypothesis. Okay, since the p value is less than 0.05, we reject the null hypothesis and accept the means are not equal. Correct? So when this value is less than 0.05, we have to reject that they are equal. We have to accept that they are not equal, which obviously if you take this mean, you will find that they are actually not equal. So basically the test is just telling you if the means were equal or not. This is used in a different industry altogether. So I'll just write this statement here. Okay, just for your convenience. Okay, clear? This is clear. What is one one way ANOVA test? Any questions on the one way ANOVA test? So I tried to find a relevant p value. This is the function, no? F one way, and I pass the data. F one way is the function. F one way is the function. I passed food 1, food 2, food 3, their mean values. I got the p value. Now clear? Yes. Yeah, it is. These are all inbuilt functions in Skype. No, it is going to take into consideration all three together or more than that, whatever groups you give. Okay, so this is having all the internal statistic modules. It's already there. Conclusion is that what was the null hypothesis? Mean is equal even after taking food 1, food 2, food 3. One is null hypothesis is mean is equal even after eating. That means there is no impact of the food on the particular, on the rats. No, there is no limitation on the groups. Mahesh Kumar, what we wanted to check was 3 different kinds of foods are tested for 6 weeks. The objective is to check the difference in mean. That means we want to check if the food is making any impact on them or not. Okay? You understood the test, why we are doing this test, Mahesh? So they took the mean of the rats. That's why I said that let's assume that there are 10 rats in each group. So after eating food 1 for 6 weeks, these were the mean of those 10 rats. After eating food 2, this was the mean. We can clearly see it has declined. That it didn't go well with them. That food they didn't accept. They didn't like. Okay. And after eating food 3, it went up. So are the 3 means same? No, they are not same. Correct. So that's why the p value is less than 0.05. Because the p value is less than 0.05, we reject the null hypothesis that the means are equal. We have to accept that they are not equal. Okay, I've made another. You can add more also. It works on multiple groups. Yes, not equal means food has different impact. Tejas, that's right. Lakshmi, does this solve your question? Yeah, so basically, because the p value is greater than 0.05, we can say that the food quality or the food actually made a difference to the rats. That is a conclusion. So we can conclude black. If I'm making 4 different types of marbles, why if I have to do a quality check, I will try to take samples, equal samples only. How do I, in a population of large population, like he said, population of India, how you can't go and check the height of every person. You are going to take certain samples only. Now, how to check if that sample is good? All that test is for that checking if the sample is good or not. Did you get the point? Different tests are there for different scenarios. Okay, like when we have groups, we want to see impact of certain things. So some tests are used in medicine. This kind of a test was used in medicine. Some test where we want to check for a certain parameter like height, weight. So those kind of tests are used. So these tests are just to check if the sample that you have picked is good or not. Clear now, everyone? So what is the 2 sample t-test? It's the same thing. We are going to take 2 samples. School. Now he wants to do with 2 schools. 0. Difference in mean is 0 means what? They are same. In short, है ना? They are same. And difference is not 0 means they are not same. As simple as that. So he's just put it in a different term. He's just put this whole thing in a different term. So 0 means that they are equal. He's checking for equality. Here he is checking for equality. That is the first one. Can you see? The mean difference is 0. So he's checking for equality. Sample underscore 1. Sample underscore 2. Okay. So is he checking for equality? He's checking for equality.
Welcome to this session on Statistics Interview Questions by Intellipaat. Statistics is by far one of the most important concepts in data science, machine learning in general. So it's an important concept, and when you're going for an interview as a data scientist or a machine learning engineer, you are expected to know a lot about statistics. So in this video, we'll take a look at some of the interview questions and their answers and try and understand what kind of questions come most predominantly in a data science or machine learning engineering interview. And these are the kinds of questions that you get related to statistics. So let's take a look at these questions one by one. Before we begin, we'd like to ask you to subscribe to our channel and click on the notification bell icon so that you never miss another update. If you like this video, click on the like button, and in the comment section down below, let us know what else you would like for us to cover next. So let's take a look at these. The first question is, what is the difference between inferential statistics and descriptive statistics? So there are different kinds of statistical measures, the different kinds of ways through which you can perform statistics. These are two of the most popular ones: descriptive statistics and inferential statistics. So to give you an exact and precise definition, descriptive statistics, as the name suggests, provides exact and accurate information, describes the data as a whole. Inferential statistics, which is derived from the word inference, is the kind of statistical measures in which we provide statistical information from sample of data to reach a conclusion about a population. So to give you an example, suppose you want to make certain kinds of assumptions about a group of people. Let's say the group of people are 100 million people, and you want to make sure that all of them are subscribed to a particular ideology. Maybe they have certain agendas, many kinds of things. So in case you wish to do that, instead of asking all the 1 million people to submit answers to a questionnaire, the better way of doing it would be to get a small subset of these people, that's called the sample, out of all the 100 million people, which is called the population. And from there on, you perform statistical measures in order to draw certain conclusions. Once those conclusions are drawn for that particular group of people, the sample, after gaining that kind of understanding, then what you can do is you can sort of think of it as being applied to the entire population. So that's the way inferential and descriptive statistics work. So what is the difference between population and sample inferential statistics? So as we have already seen, population is the larger context and sample is the smaller context. But to broaden it out a little bit, from the population, we take the sample. Now, think of it as an entire body of work and then some piece of work from there. So we cannot work on the population either due to computational cost or due to the availability of data points for the population. Another way of thinking about it would be to think about it in the way that you have some data. You have a large number of data about a lot of people, but you can't use all of it because it's a huge number of data. That's not really possible for you to compute the entire piece of data. But what you can do is you can randomly select a little subset of that data and draw conclusion from that. So this is what's called statistical measuring in inferential statistics. And from here we take the sample. Sample is the small subset that we chose, and population is the larger subset from which we choose the sample. There are different ways of choosing the sample. We have to be very careful when we're choosing a sample data from a population, because we don't want to take wrong samples or take samples in a way that causes certain kind of biases. We'll cover those in future questions, but we don't want to make mistakes in this step, because this is the step that forms the foundation of everything that we're going to be doing as we move forward. So from the sample statistic, we calculate the statistic. Now, after that, getting the sample data from the population data, we perform the inferential statistical methods, and with that, from the sample statistics, we conclude about the population. So this small group of data set that we use in order to draw conclusion about a larger data set. All right, let's take a look at what is quantitative and qualitative data. So these are two kinds of data sets that you might have to deal with: quantitative and qualitative. It's quite easy to understand what these mean if you take a look at the etymology of the words. In quantitative data, it deals with quantity, so it's known as numeric data. If you're ever dealing with numbers, age, number of people that subscribe to a particular channel, number of people around a particular age, any kind of quantity, the number of people who bought a particular phone, the amount of phone that was sold over a period of time, the amount of product that was sold over a year, these kinds of things, they are quantitative data that tell you about the quantity of something that you wish to know. Qualitative data, on the other hand, is also called categorical data. This is data that is not numeric in nature. So this is someone's name, identity, gender, you can also think of it as the age group, like a toddler, a teenager. These are not numeric values because a teenager could be anyone, either 12 years old, 13 years old, 14 years old. They are all teenagers, whether they are old or whether they are young. These are the kinds of things that are known as qualitative data. They tell you about quality of a person or quality of a data point. So this is what the difference between quantitative and qualitative data is. Then comes the 5-number summary. This is by far one of the most important concepts and one of the most asked questions in statistics to sort of gauge your understanding of how much you know about statistics. This is also one of the most basic things that you should absolutely know. So the 5-number summary is a summary of data extracted usually in descriptive statistics. So when you're trying to describe the entire data set, you get some data and you create a 5-number summary of that data. This summary usually contains information such as low extreme, which is the minimum. So if I give you a bunch of numbers and I ask you, okay, tell me the number that is of the minimum value in this collection of numbers. That's the first thing if you are trying to create a 5-number summary. Then there's the lower quartile, which is Q1, which is the 25th percentile if you would like to call that. Then there's median, which is the 50th percentile. Then there's upper quartile, which is Q3, which is 75th percentile. And then there is upper extreme, which is the maximum value. Now, of course, 5-number summary is not the only summary that you can draw. You can add more things into it, such as the mean, the standard deviation, and all other kinds of things. But to get started, this is the best way to sort of give you a summary of the data that you have. What is the range of the data, that is from minimum to maximum? How is the data spread out? What is the data point right at the middle, which is median? What is the data point at the 25th percentile, which is the data point that is between the minimum value and the median value? Similarly, Q3 is the value that is right at the middle of median and the upper extreme or the maximum value. So that's how you can sort of show the distribution of the data and how the values interchange and how the values are spread over the entire number line. So what is the benefit of a box plot? So box plot is by far one of the most misunderstood concepts in statistics. Box plots are used predominantly when we're trying to give you a visual representation or graphical representation of the 5-number summary. And it also can be used to compare groups of histograms. Since histograms are just quantitative data, we can generate a 5-number summary from that histogram, and then we can create a box plot out of it. Other plots such as pie charts and scatter plots and all of that, they are quite easily understood because they're very intuitive. You take a look at that, you take a look at pie chart, you figure out, okay, this is the percentage of a share from 100% of a value. So that's how you can understand that. Scatter plot tells you the relationship between two values and many other kinds of things. Do the value cluster up against each other? Do the values spread out over the entire sheet? How does that work? So that's the way these things work. But box plot is a little misunderstood because it's not very intuitive. When you take a look at a box plot, it doesn't make much sense. So if someone asks you, and this is why the statistical interview questions ask about box plot, because as 5-number summaries are really important, and it's important for you to be able to visually understand what a 5-number summary represents. You draw a box plot so that it can be shared with different people, and you can compare and contrast different box plots. So a box plot is basically a graphical representation of the 5-number summary. You get all the data that you have gotten previously in the 5-number summary, but you represent it in a way that's easier for you to comprehend and easier for you to explain to other people. So that's what the 5 box plots are there for you to do. The next question is, what is mean? Now, again, this might seem like a really simple question, but mean is actually one of the things that people find it really difficult to define. Many people define it as simply being a summary of the entire data point, which is very vague and not very useful. If you're trying to learn something, you should make sure you understand what it means, since mean is one of the most basic and one of the most important concepts. This is a question that is asked most frequently. Now, the answer to this is quite simple. Mean is the average of a collection of values. Calculation of it is very simple. You just calculate it by dividing the sum of all observations by the number of observations. So if you have 5 numbers going from 1, 2, 3, 4, 5, you calculate the sum of those numbers, which is 15, and then you divide it by the number of observations, which is 5. 5 divided by 15, you get 3. 3 is the mean of the values. So that's how you create the mean. You understand what the mean is and how you calculate it. Now comes standard deviation. Even though mean is quite misunderstood, standard deviation is a little difficult for people to explain in succinct terms. So if it gives off the representation that you don't know what you're talking about when you're talking about standard deviation. Standard deviation is not that difficult to understand. As the name suggests, it is a magnitude of how far are the data points from the mean, or how much do they deviate from the mean. So if I calculate the mean, so how many value, what is the magnitude by which these values deviate from the mean or are spread out around the mean. It gives you an idea of how the spread of the data is going to be if you draw a curve of data. If you were to plot it, how far away does the spread go? That's what standard deviation is. So let's suppose that you have a value set and you get a mean of 5 and the value of minimum and maximum is 0 and 10. So the mean is quite close to the extreme ends of the data, and even if you were to plot it, you would get simple plot and it won't be very spread out. On the other hand, if it was like you get a mean of 15 and you have values of negative 35 and positive 157, then the mean is somewhere around the middle, but the problem is that the data is quite spread out. So that's how the spread of the data is defined. So that's one way to think about it as well. That's what standard deviation is all about. It's a magnitude of how far are the data points from the mean, how far is the data spread out from the mean, to be exact. Then comes symmetric distribution. This is another important concept because it's a little difficult to explain in a simple, succinct manner. When you're in an interview, people are looking for you to describe these basic topics in the best possible way, which is why these questions are asked so often. If you fumble in these topics, then they know that either you have no confidence in what you're talking about, or you don't know what you're trying to tell them. So what does symmetric distribution mean? This is an important question because symmetric distribution is at the heart of many of the statistical techniques that we take a look at. So a symmetric distribution means that the part of the distribution that is on the left-hand side of the median is the same as the part of the distribution on the right-hand side of the median. For example, and there are many examples of symmetric distribution: uniform distribution, binomial distribution, and normal distribution. Symmetric, for those of you who are unaware, is a term that means that if you were to cut something from the middle, create a half portion of it, the left hand side portion will be exactly the same as the right hand side portion. So this is why it's called symmetric distribution, because when we create a distribution plot, as you can see in the image here, it is supposed to look exactly the same from the left hand side portion to the right hand side portion. If I were to fold it over onto itself, it should exactly cover the other side. It should not spill over and it should not leave some space. That's the way that symmetric distribution works. Then comes, what is the relationship between mean and median in a normal distribution? So this is a question to help you understand what is mean and median and what makes a normal distribution stand out. So when you calculate some data of data that is giving you a normal distribution, which is a symmetric distribution, what is the definition or what is the relationship between mean and median of that data? So in a normal distribution, mean is equal to the median. So to again give you an example, if you were to create a plot of data such as 1, 2, 3, 4, 5. So you have 1, 2, 3, 4, and 5. Calculate the mean of the data, you get 5 plus 4 plus 3 plus 2 plus 1, which is basically just 15. Divided by 5, you get 3. Similarly, the median is going to be, since it's all in one line and it's all in ascending order, we get 3 as the median. Since mean is 3 and median is 3, it's a normal distribution. If you were to plot it, you will get a normal distribution as well. Of course, in real world, the data is not so easy to interpret. There's a lot of data, all of it is jumbled up and it's difficult to grasp. You make use of certain computer programs, you can make use of certain statistical measures, but at the end of the day, if you want to figure out whether or not plotting something will give you a normal distribution, just calculate the mean and the median and take a look at the difference between the two. If the difference is not large, then the mean and median will give you normal distribution or almost a normal distribution. But if it is too far off from each other, then it's going to not give you a normal distribution, but it's going to give you distributions that are skewed. And we'll take a look at what a skewed distribution means in a moment. So what is an outlier? Outliers are by far one of the most common problems that we get when we are dealing with data. This is why we get questions like these asked in data science and machine learning engineering interviews. Data science makes heavy use of data sets, and if you don't understand what an outlier is and how it affects your entire process of machine learning, or how it affects your entire process of modeling the data to create a predictive model, then you don't really understand how data science works. So before understanding how it affects our models, we have to understand what an outlier is. An outlier is a value in a collection of values that is either much larger or much smaller than other values in the collection. To give an example, let's say that you have 5 values. You have 1, 2, 3, and 4. These are the first 4 values that you get. All of these values are quite compact. They are quite close to each other. There's not a lot of difference between the extreme ends of the 4 values that we have gotten. But let's say that the fifth value that we get is 157. This is quite far off from all the other values. It's not the same as all the values that we have gotten. It's quite far off from what we would like to use. So how do you deal with that? That's called an outlier. Similarly, if it was like negative 251, it is also an outlier. Outliers can lie on either end of the number line. If you put your data on a number line and some data are at the extreme end of the value spectrum, that means that you are facing problems with an outlier. They negatively impact your statistical models. So if you're trying to create a model that can predict the next number, so 1, 2, 3, 4, if that's the data, then the next number is going to be 5. This is quite easy actually, but you can see how easy it is. Now let's say one value is an incorrect value that we get. It's 157. Now our statistical model is entirely confused. It thinks that 80% of the data is conforming to one pattern and 20% of the data is not conforming to that pattern, and it is very difficult for it to make sense of this difference in the magnitude. So to deal with outliers, we'll take a look at how to deal with outliers. But first you need to figure out how can you find out an outlier. An outlier is a difficult thing to understand at first, but how can you find it out? Once you know that you might have some outliers, when you're dealing with data in a large scale, finding out outliers, it can be a bit difficult to do by hand. So you need help of certain formulas. Now, this is where the 5-number summary comes into play. This is why we discussed it in the earlier sections, and this is why it's so important to know what a 5-number summary is and how you can calculate it. So you can use the 5-number summary to identify the outliers. Any values smaller than Q1 subtract by 1.5 times the IQR. These might sound like terms that are not very easy to understand. So Q1 is the first quartile, is the 25th percentile. It is the value. So if you take all the values and find the value that is right in the middle of the entire collection of data, if you put it in ascending order, that's the median. And if you find the value in the middle of the smallest value and the median value, that's the first quartile. That's the 25th percentile. So you get that value, and then you subtract 1.5 multiplied by the interquartile range. This is the value that is interquartile range means the magnitude of the difference between Q1 and Q3. So you get 75th percentile, you get the 25th percentile, and then you subtract them with each other. Whatever value you get, that's the value that you can consider as the interquartile range, or the range of the quartiles. Then you multiply it by 1.5, which is basically you are expanding the value a little bit more. You are making it 1.5 times of what it is. You're making it larger than what it is. And then you subtract it from Q1. So you get some value at the end of Q1, and then you sort of expand it a little bit. Any value that's smaller than that is an outlier. It's a data set that it's a data point that should not really be there. It doesn't make sense for the data to be smaller than this number. So that's the number that you can think of. But that's only if the data, an outlier is in the negatives or is smaller than the smallest value. What about the largest number? Now that is where the Q3 comes into play. So you take Q3 and you add 1.5 multiplied by IQR, which is the interquartile range. So on the other hand, the number that are higher than what the maximum value should be, that's the other kind of outlier. And to calculate it, you do this. So if your number is smaller than first quartile subtracted from 1.5 times the interquartile range, and if a number is larger than third quartile plus the 1.5 times interquartile range, then it is considered an outlier. So that's how you can create an outlier. To deal with an outlier is quite simple. You remove the outliers without thinking about it, because outliers are really detrimental to our statistical measuring. Outliers exist because of problems in statistical measuring. When we're trying to take the sample, some data sets are just too different from what we expect, some exceptional data points, or it could be issues in the measuring devices that we used. If you're trying to take temperatures, maybe the thermometer was broken and it didn't give the right reading. Maybe it was polluted, something happened and we get the wrong inputs. And these wrong inputs affect our statistical models because the reality is not based on the outliers, it's based on the collection of data that is quite close to each other. Now let's take a look at what is the relationship between mean and median in a normal distribution. So in a normal distribution, mean is equal to the median. As we have taken a look at symmetrical distribution, normal distribution is just another name. This is a question that is used to throw off people from what they are trying to learn. So if you know that symmetrical distribution is normal distribution, then it's going to be really easy for you to use. But these questions come in quite handy because when people are studying these things, they learn that, okay, symmetrical distribution, you have mean and median, they're equal to each other. But if you learn the normal distribution, you learn that mean and median are equal to each other. And then you go to an interview and they ask something else. So if you've learned symmetrical distribution and they ask normal distribution, you should not be confused and thrown off the scent. You should understand that these are the same things and they have the same value. So mean is equal to the median. These questions are quite frequent. They try to get a sense of a person's understanding of how much they know about statistical measuring, how much they know about symmetrical distributions, how much they know about distributions that are the same with different names. So that's how this works. So what does the bell curve distribution mean? This is a term that is used quite frequently when we're trying to describe a distribution in our statistical measurings. So what does it actually mean? A bell curve distribution, or a normal distribution as it might also be called, is called a bell curve distribution because of the shape of the distribution that looks like a bell. If you've ever taken a look at a bell at any place, it looks in the shape of a bell curve distribution. If you take a look at the image that is at the top right next to the calculator, you can take a look at it and you can imagine why it's called a bell curve distribution. It is symmetrical. It is looking like a bell, so that's why it's called a bell curve distribution. Bells are also quite symmetrical, so that's one of the reasons why it's called that. So how does standard error and margin of error are related? So what happens to standard error as the margin of error decreases or increases? What is the relationship between the two? So as the standard error increases, the margin of error also increases. This is also known as a positive correlation. So when one value increases, the other value increases as well. Think of it as the relationship between the age and height. As the age of a person increases, their height also tends to increase. However, that relationship isn't carried for a long time. After a certain age, your height stops increasing. But as a good threshold, you can understand that how that works. So that's how the standard error and margin of error are related to each other. And now we come to another question that comes into hypothesis testing. If you've ever worked with statistical analysis and understanding the data, one of the things that we get to understand is what does the degree of freedom mean? So as the name suggests, degree of freedom is defined as the number of options that we have. So if we want to take a look at a new scheme that a cinema hall has introduced, it has introduced three kinds of popcorns. Three kinds of popcorn buckets or snack buckets: a small bucket, a medium-sized bucket, and a large-sized bucket. And we want to take a look at what do people prefer to choose most of the time or in a particular cinema hall. So this is where we get the word degree of freedom. The person who is being studied has three options, three choices: the smallest box, the medium-sized box, and the largest box. So it is used with T distributions and Z distributions. These are the kinds of distributions that we use when you're trying to make sure that the population sample that you have chosen and the conclusion that you have drawn with it is in congruence with the entire population. So you take the entire population and you take the sample statistic and you try to figure out whether or not the conclusion that you drew about that conclusion is in line with the entire population. That tells you the sampling was correct, that there was no error in sampling, and so on. So the degree of freedom basically means that the number of options that you have. Whenever you're trying to create a statistical model, you need to provide it with certain options. An option could be as simple as a binary option in which either a person chooses to buy something or they choose to ignore it. or it could be a larger, broader spectrum of options. Out of the 10 ice cream flavors that were given, which one did the most people go for and why? What were the genders of the people who went with the one kind of flavor, and what was the gender of people who went with other kind of flavor? So these are the kinds of things that we're talking about. If they were given 10 kinds of ice cream flavors, then they have a degree of freedom of 10. If they were given 3 kinds of boxes of popcorn, then the degree of freedom is 3. And this is what is used to determine whether or not the conclusions that are drawn prove the hypothesis or disprove the hypothesis. So now let's take a look at what is covariance. So covariance is a measure of how two variables change together. Now, if you have ever worked with statistical modeling of data, if two variables have a strong relationship with each other, that means that one variable values in one variable change as the value in another variable change, we're trying to create a model that could have a negative impact. It may also not, but if the relationship is really, really strong, then it could have a negative impact on the kind of model that we're trying to create. So it's important to understand the relationship between different variables. Now in this one, we have what is covariance. Covariance is the measure of how two variables change together. Does the increase in one variable lead to an increase in another variable, or does it lead to the decrease in another variable? Is the covariance positive, negative, or neutral? Neutral basically means that there is no relationship between two variables. One variable increases has no effect on another variable. So to give you an example of these kinds of relationship, think of it as this. You have some data set that has a person's age and date of birth. As the date of birth increases, the age is also going to increase because these two things are calculated on top of each other. So that's really easy to understand. Then comes the after date of birth, there's for negative correlation, we have or for positive correlation, another example could be a person's age and their height. So as the age of a person increases, the height of the person also increases. So one has an effect on another. Then comes neutral covariance. In the neutral covariance relationship, what happens is change in one variable has no effect on the change of another variable. So a person's you can think of it as a person's choice of food and their income level. That could be a relationship of neutral correlation because there doesn't seem to be much relationship in these two things. Then comes negative correlation, in which increase in one thing leads to decrease in another. So you can think of it as a person's age and their bone density. As the person's age increases, their bone density starts to decrease when they start getting older. So these are kinds of things that you can take a look at. So that's what covariance does. It tells us whether or not the change in one variable has effect on other variables. Let's take a look at one sample t-test. So in case you're not familiar, one sample t-test is a kind of statistical hypothesis testing. One sample t-test is one of the kind of t-test you can do. You can also do two sample t-tests and other kinds of t-tests as well. So one sample t-test is a statistical hypothesis test used to determine whether an unknown population mean is different from the specific value. So a good idea to understand this is basically if you are trying to create a data, you're trying to draw some statistical inferences from a student's data set. You have data about each specific student and you want to figure out whether or not that particular data about that student is in congruence with all the population data that you have. So you usually use t-tests when you have continuous data. So for instance, you have data about a person's age, that's continuous data. Stock prices, when you have stock prices, when you have blood charts, diabetes charts, these kinds of things. So what it allows you to do is it allows you to determine whether an unknown population mean is different from a specific value. So if we have a specific value for a sample data and we want to take a look at the mean of the entire population, does that signify a significant difference that we can measure it as an outlier or something like that? That's what one sample t-test allows us to do. Then comes alternative hypothesis. So alternative hypothesis is also denoted by H1. This basically is a statement that must be true if the null hypothesis is false. Think of it this way. If you have an alternative hypothesis, that means that the statement is true when the null hypothesis is false. So these two things are diametrically opposed to each other. Now, if you think about it, in statistical measuring, we are trying to prove something. that something is written down in a hypothesis. So we have two kinds of hypotheses, as we have already discussed: null hypothesis and alternative hypothesis. Null hypothesis is something that is in inferential statistics. The null hypothesis is the default hypothesis that a quality to be measured is zero. To give you another example, let's say that you're trying to draw a conclusion about a group of people in a large population, and the conclusion that null hypothesis will allow you to do is it allows you to prove the negative. It allows you to prove that, okay, we are trying to prove that this group of people is representative of the entire collection of population. But in null hypothesis, you write it in a negative way. You write, okay, this population is not representative of the entire population. On the other hand, in alternative hypothesis, you will write, no, this population or this group of people are representative of the entire population. Then you perform your statistical inferences based on the data that you have, and you make the conclusions thereon. It's called the null hypothesis or the default hypothesis because we tend to measure it towards zero or negative things. So that's why it's called null hypothesis. On the other hand, alternative hypothesis is trying to prove something in a positive direction. So that's why it's called alternative hypothesis. Now, in the next question, we're trying to understand when you are creating a statistical model, how do you prevent overfitting? Overfitting is by far one of the most common issues that comes with statistical modeling. This is the kind of problem that you get when you have some training data and some testing data. You create a statistical model using the training data, and in the training data, when you again try to make the predictions, you get 100% prediction. On the other hand, in the testing data, when you try to pour in the data and get the responses, you get really varied result. The accuracy is really low, around 50%, 40%. So when you're creating a statistical model, you get this overfitting problem when the data set that you use for training leads to a good performance when you use it on the model, but on the testing set, it is very poorly performing. This is because the statistical model essentially analyzes and then remembers everything about the training data. So when it's being trained, it takes a look at all the values and it draws the conclusion that, okay, I have remembered everything. Now when these values come, and I will be able to answer it perfectly. But if, for instance, a new value comes in that the model hasn't seen, it will have no idea and will just try to guess it, and it will get it wrong most of the time. That's what overfitting means. How do you prevent overfitting? You do it by cross-validation. Cross-validation basically means you get the data set that you want to train your data on, put it in 10 different groups. So basically divide the data set into 10 parts. Then generate the model and use 9 parts for training and 1 part for testing. That 1 part, you are going to alternatively pick all the 10 parts one by one and let all the other 9 parts be for training purposes. That's how you can do it by cross-validation. Then comes skewed distributions. In case you're not familiar with skewed distributions or distributions in general, distributions basically mean how do you plot a data and how the frequency of the data is determined here. Now, there are two kinds of skewed distributions: left skewed and right skewed distributions. So what is left skewed distribution? A left skewed distribution is one where the left tail is longer than the right tail. So it is important to note that in a skewed distribution, mean is smaller than median and median is smaller than mode. For those of you who don't understand what mode is the value that is occurring most frequently. If I have 5 values and they are 1, 2, 4, 5, 5 is the mode of the values because it occurs most number of times. Now, when we take a look at left skewed distribution, it is different from symmetric or normal distribution. In normal distribution, mean is equal to the mode and the distribution is completely symmetrical. It's same on the left hand side than it is on the right hand side. In left skewed distribution, however, the tail is longer than that of the right tail. So on the left hand side, there's a longer tail to the distribution than there is on the right hand side. It is important to note that the mean is smaller than median and median is smaller than mode, other than the ones that we take a look at in normal distribution, in which mean was equal to the median. Here the mean is smaller than the median. Then comes what is right skewed distribution. So similarly to left skewed distribution, right skewed is the diametric opposite of that. You get a right skewed distribution when the right tail is longer than the left one. So if the right tail is longer, left tail is shorter, then you get mean that is larger than the median and median that is larger than the mode. So hopefully that makes it clear. In normal distribution, mean is equal to the median. In left skewed distribution, mean is smaller than mode. And in right skewed distribution, mean is larger than median. So that's how this works. Mean and median, the relationship between mean and median can be used to describe what kind of a distribution we'll get if we plot the entire data set. So if you have calculated the mean and median, instead of plotting the entire data set, you can simply take a look at and compare the mean and median to figure out what kind of a distribution will it provide you with. You can also calculate the mode. However, mean and median tend to have the largest effect on these data sets. So here's a question that gets asked very frequently. The values might change, but it gives you a good understanding of how you can use the quantities in your understanding of a hypothesis. If a distribution is skewed to the right and the median is 20, what will be the mean of the data? Will it be greater or less than 20? So basically the question is the mean greater than the median or is it less than the median in a right skewed distribution? Since we saw it just now, if the given distribution is right skewed, then the mean should be greater than 20, while the mode remains to be less than 20. So that's how it's supposed to work. Mean is the greatest, then there's median, which is smaller than the mean, which is 20. Median is 20, mean is supposed to be greater than that. How great, it doesn't really matter. And mode is the smallest value in this entire equation. So that's how the right skewed distribution works. Then comes, what are the kinds of biases then you can encounter while sampling? For those of you who are unaware, sampling is the technique that you use in order to extract some small sample out of a large population of data. So different kinds of sampling are available. In medical field, they use different kinds of sampling than in statistical fields. One way to sample is, let's say that you are trying to collect some data about medical patients. So you can take a look at every third patient that comes in and you use that third patient's data. So now your data set that you have will be reduced by a third. So instead of if 100 patients or 33 patients come into your clinic every day, you only have data about 11 people. So now you have only 11 people. They are selected randomly. Whoever comes first, second, or third, you don't change the order. You just keep the order and pick the third person. So that's how you can do this. Now, there are certain biases. Biases are basically errors in sampling. When you're sampling something, you end up choosing one over the other, and that leads to some error. So what are the three kinds of major biases that you could have? These are selection biases, survivorship biases, and undercoverage biases. These are all important biases, and we'll take a look at those one by one. But it's important to understand that these biases heavily affect the information that we get, and if we get wrong information, we're going to draw the wrong conclusions about the entire world, about the entire population of the data that we have. So let's take a look at selection bias first. This is an important question. Usually people start by asking the different kinds of biases and then they go one by one. If you're confident enough and you answer one of the biases with a good level of confidence and understanding and good wordings, they might not ask you about different kinds of biases because they know that you know what you're talking about. But in case you don't, they still ask you. So what is selection bias? Selection bias is a kind of error that occurs when a researcher decides who is going to be studied. So basically, selection bias occurs when a researcher who's supposed to research the entire data set gets to make the decision about what are the people who are going to get studied. This is not done randomly. This is done on the basis of preconceived notions by a particular researcher, and that could lead to really difficult problems. So in order to say that, let's say that you are trying to study the population of an entire city, and what you do is you just say, okay, give me the top 10 earning people of the entire city. Now the population is not going to be represented by the sample. You only get the top 10 most highly paid individuals. You might not get everyone, and your study might be really off to what the conclusion should be. Now, it could be possible that the conclusion that is drawn could be correct, but you will never know unless your sampling technique was correct. So that's a selection bias. Then comes survivorship bias. Survivorship bias draws its name from the word survivor. That's the keyword here. Survivorship bias is the flaw of the sampling technique, sampling selection technique, that occurs when a dataset is only considering the surviving or existing observations and fails to consider the observations that already ceased to exist. If you're trying to study about certain species of fishes, make some conclusion, then the species that have disappeared throughout the history of living creatures, those species are not considered, then your results might be a bit off. So that's survivorship bias. You can take a look at other nuclear disasters or man-made disasters in which people died, and if their data is not considered, then you might not get an accurate picture of what the data set that you're trying to get is. So that's survivorship bias. And then comes undercoverage bias. So undercoverage bias is a bias that occurs only when some members of the population are inadequately representative or undercovered in a sample. So let's say that you are trying to predict you're trying to make a prediction about certain people. The population contains 30% of the people in the population are below the age of 18. The rest out of the 30%, if you remove the 30%, out of the 70%, 60% are above the age of 18 but below the age of 40, and rest 10% are above the age of 40. So that's how you get it. You get 30% less than 18, 40% out of the 70% to be, or let's say like 60% out of the 70% to be between the ages of 18 to 40 and 10% above the age of 40. Now, when you're trying to create a sample, let's say out of those 100 people, you're only trying to get 10 people, then you need to be able to take into account all of this and create as close to possible the real world situations as you can. So, and you pick many ways of doing this. One of the ways is you take a look at the different categories, take a look at the distribution throughout the population, and then you choose that many people. So since there are 30% people below the age of 18 in our population of 100 people, we take 3 below the age of under 18 people through the population. Therefore, our sample. For the next, we have 60% of the people between the age of 18 and 40. So we take 6 people out of that age group in the population. And finally, we take 1% above the age of 40. So we have an accurate representation of the entire population. If we don't do this, then we get a bias in our entire research, and that bias is called undercoverage bias. This is really important to be understood, because if the bias is giving us the undercoverage bias, then our data set is not representative of the population, and we get a lot of errors throughout the entire thing. So we need to be able to cover for that undercoverage bias and understand if it has occurred. If it does occur, then we need to understand how to use it in a better way. Then comes skewness. So this is a question, as we have already taken a look at what is right skewed and left skewed. The question here is, what is skewness? So it is important to be able to describe what skewness actually is. Skewness is a measure of a lack of symmetry in data distribution. If you want to take a look at how skewness works, basically you have symmetrical distributions, and if it's not symmetrical, then it's either skewed on the left or on the right. These are the only 3 options that you have. So that's what skewness is all about. It's about a lack of symmetry in the distribution of the data that we have. Then comes kurtosis. This is a concept that not a lot of people take a look at. It's a scary sounding word, but it's actually quite easy to understand once you wrap your head around the entire idea of skewness and kurtosis. But kurtosis is basically used to describe the extreme values in one versus the other tail. It is actually a measure of outliers present in the distribution. So if you have an entire population and you have values on the extreme end of one point, so there are values that are below the necessary values in the first quartile and above the necessary values of third quartile. So you have outliers on both the extreme ends. Then there's a high kurtosis. Kurtosis is used to describe the extreme values in one versus the other tail. So what are the values that are on one side of the number line, and values on the other side of the number line, going in the positive direction and in negative direction. How many outliers are there? What are the kinds of outliers that are present? And that's the kind of thing that kurtosis allows us to figure out. Then comes correlation. Now, correlation is used to test the relationship between quantitative variables or categorical variables. They sound very much similar to covariance. The important distinction between correlation and covariance is that correlation is used to measure the magnitude of the relationship. So correlation usually ranks from -1 to +1. So the value of a correlation between 2 variables is going to be from -1 to +1. -1 being an extremely negative correlation, +1 being the extreme positive correlation, and 0 means there is no correlation. Now what that means is, in covariance we try to figure out whether or not the relationship is proportional or inversely proportional. That is, a value increase in one variable is going to lead to the increase in value in another variable, or is it going to lead to the decrease in value of another variable. On the other hand, in correlation what we get to get the magnitude of the covariance. So to give you an example, how much will a particular change in one variable lead to a change in another variable? Whether it's positive or negative, that's a different thing, but how much is it going to be? So if it's 1, then it's going to be increasing as much as the positive value increases. So to give you an example, if I have 7 as a value, I increase it, the other value that has 3 will also increase by 1 or 2, whatever. So that's the thing that we're trying to get across. It's the magnitude of how strongly these values are correlated that determines whether or not change in one value is going to lead to change in another value, and how much is it going to be. So now no one usually gets zero correlation. Each value is due to some inferences and noise in the data get some sort of correlation between two variables. But in order to regard these two correlated variables, what we do is we take a look at the correlation and we try to figure out what could be causing that correlation instead of focusing on the little details. So if you have two variables that are correlated by the degree of 0.2, 0.3, then it's not significant and you don't need to worry about it. If it's above 0.5, let's say 0.6, 7, 8, 9, or 1, or below 0, negative 0.5, negative 0.6, 7, 8, 9, 10, then that means that you are running into an error. And a lot of correlation of variables are strongly correlated, then you need to drop one of the correlated variables. So you just need to understand that. Finally, we have the relationship between standard deviation and standard variance. These two things sound very similar, but they have a really different measures. So standard deviation is the square root of standard variance. This question can also be asked in a reverse format, which is how does standard variance relate to standard deviation? The answer would be it is standard deviation squared. Standard variance is the standard deviation squared. So you multiply standard deviation value by itself and you get standard variance. These are just used to determine how the values work and how to use them. This question is asked mainly because people get confused between standard deviation and standard variance, and that could lead to a lot of confusing issues. So these are the kinds of things that you should understand when you're trying to learn these technologies and learn these terminologies, because the problem here is that deviation and variance are quite closely related. But how do they relate with each other? Which value is the square root of which value is going to be the deciding factor of whether or not you're right or wrong. With that, we have come to the end of all the questions that.
Just a quick info, guys. Intellipaat offers a data science course which will help you master Python, SQL, machine learning, AI, and Power BI. Get a data science certification from IIT Empowertak and Innovation Hub of IIT Madras. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height. So visit the course page link given in the description and take the first step towards the career growth with the data science course.